Hey guys, I hope you guys are doing well, and I'm sure you guys are studying hard. So, for those that don't know me, my name is Daniel. I'm a GCSE and A-level maths tutor, and this is my YouTube channel, Maths with Dan, where you can find many walkthroughs on A-level papers such as these, GCSE papers too. I also do predicted papers now, and I also live stream as well. Every summer, I start live streaming with exams around the corner. So yeah, today is the paper one of the Edexcel A-level maths exam in June 2024. So there was a couple of questions in here. There was 15 questions, a couple of tricky ones, but I'm sure you guys are always studying very, very hard. So I'm sure you'll find it okay. The timestamps will be in the description. And yeah, so it's currently October, and I'm also currently on 9,000 subscribers, guys. So it would be amazing if I could reach my goal of 10K by the end of the year. So if you do know anyone that would find this video helpful and all the other videos I have helpful, which are GCSE videos, A-level videos, predicted papers, then feel free to share my videos with them so we can reach that goal together, because it's a team, it's not just me, it's we're in this together, so yeah, but yeah, that's pretty much it in terms of the intro. Let's get into the walkthrough. Okay, so question one says g of x is equal to 3x cubed minus 20x squared plus k plus 17x plus k, where k is a constant. Given that x minus 3 is a factor of g of x, find the value of k for 3 marks. Okay, so this is just a factor theorem. And from this, remember, you make this bracket equal to 0. That means that x is 3. It must mean that g of 3 is equal to 0. So all you're going to do is you're going to sub in 3 into your function, set it equal to 0, and that will allow you to find out what k is. So let's go ahead and do that. That's going to be 3 lots of 3 cubed minus 20 lots of 3 squared plus, there's a 3 right here. I'll put at the front though. So k plus 17, like that, plus k, and that has to equal 0, isn't it? So dealing with that, what's 3 to the 4? That's 81. 3 squared is 9 times 2 is 18. That's 180. Like that. That is 3k plus 30, 51 plus k is equal to 0. What's that? I've got a 4k there. I've got 81 minus 80, which is 99. Yep. So we've got minus 99 plus 51 is equal to 0. What is that equal to? 99 minus 51 is 48. So that's minus 48. So we've got 4k minus 48 is equal to 0. So that must mean that 4k is equal to 48. So therefore k is equal to 48 divided by 4. Half it twice, k must be equal to 12. So therefore k is equal to 12. And that is it for part A, or for this question one. Okay, so question two says, find in ascending powers of x the first 4 terms of the binomial expansion of 1 minus 9x to the half, given each term in simplest form for 3 marks. So this is just standard binomial expansion, the fractional version of the formula where you have a power which is either negative or fractional. So what I always do is I always write first. So general formula is 1 plus ax to the power of n. This is equal to 1 plus n ax plus n minus 1 over 2 factorial, and then times by ax all squared plus n minus 1 n minus 2 over 3 factorial, and then ax all cubed, and so on and so forth. Now they want the first 4 terms, so we'll just stop here. What I like to do is I just literally just compare it. So I've got 1 minus 9x. So I write this as 1 plus and then put a minus 9x there, like that. And then this is to the power of a half. And that tells me that our ax in our case, our ax is going to equal minus 9x, and our n is going to equal 1/2. And then you just simply plug everything into that formula. Very, very straightforward. So doing that is going to be, I'll do it here. It's going to be equal to 1 plus n is a half, so it'll be 1/2, and then ax, which is minus 9x in this case, so minus 9x, like that, and then plus n, which is a half, and then a half take away 1. I'll do it bit by bit just because it's a walkthrough. So 1/2 take away 1 over 2 factorial, and then minus 9x all squared, and then plus, and then 1/2 and then 1/2 minus 1, and then 1/2 minus 2 over 3 factorial, and then minus 9x all to the power of 3. And all you've got to do now is just simply simplify and expand everything. So let's tidy up a bit. So we've got 1 there. We've got 1/2 times 9, so that's minus 9 over 2. So that's fine. And then we have, what I always do, especially when I'm teaching this, I was teaching this yesterday actually. Let me evaluate this just in my head first. So I've got 1/2 like that, and then that's going to be minus 1/2 over 2 factorial. I know that's 2, but I'm just going to leave it like that anyway. And then what I like to do is I expand this just so I can get the coefficient of the x squared term, and then I can times it by everything else on the left of it. So minus 9x all squared is going to be a positive 81x squared, isn't it? So it'll be 81 and then x squared like that. And then this one is going to be plus, and then that's going to be 1/2. That's going to be minus 1/2. That's going to be minus 3 over 2, isn't it? That's going to be over 3 factorial, which we know is 6, but I'm still going to leave it like that. And then that one, that's going to be negative. I don't know what 9 cubed is. I think it's 729, I think, but let's just check anyway. 9 cubed, because I think I saw that number somewhere before. Yes, 729. So that's going to be negative 729 x cubed, isn't it? We know it's negative because that power is odd. So I've got an odd number of negative signs, so it's going to be negative. So all we do now, very, very simple. You're just going to plug this into your calculator, and that will give you the coefficient of each of these. So I'm going to highlight this so it's super clear. I'm going to plug that in. I'm going to plug that in and see what I get. So the first one, let me write this out again. So it's going to be 1 minus 9 over 2x so far. There's one negative there. So I know it's going to be negative overall, but let me just put it into the calculator and see what I get. So I'm plugging in. I can do it here actually. I'm plugging in. I need 1/2. I can do it like that actually. 1/2, and then minus 1/2. Like that, and then over 2 factorial, I'm going to go to option, I'm going to go to F6, I'm going to go to prob, I'm going to get the factorial symbol there. So 2 factorial like that, and then times by 81. And that gives me minus 81 over 8. So therefore, it's going to be minus 81 over 8, and then the x squared like that. And then the next one is going to be negative, isn't it? Because there's 3 negative signs. So I'll just put that there already. But then I'll just, you know what? Let me take that off. Just plug all of this so you'll get the same thing. So plugging that in now. I'll just edit this one because it'll be faster to do that there. What do I need? I need to change it to a minus 729. So that goes to minus 729 like that. Whoops. And then I need to change that to a 3 factorial, don't I? So that is going to become a 3. And then I need to put a minus 3 halves, don't I? So minus 3 over 2, like that. Close bracket. Let me just double check that looks all good to me. Perfect. Execute. And I get that there. So that is my coefficient for the x cubed term. So it's going to be minus 729 over 16, isn't it? X cubed. And that is it. That is your answer for part A. So let's go into part B. Okay, so part B says, give a reason why x equals minus 2 over 9 should not be used in the expansion to find an approximation to root 3 for 1 mark. So remember when you're dealing with binomial expansion, right? Your expansion are only valid for certain values of x, isn't it? So generally speaking, remember, if I've got 1 plus ax to the power of n, then this expansion is valid. This is valid for when the modulus of this thing here, right? So the modulus of ax is less than 1, right? So in our case, remember, we had 1 plus, and it was minus 9x, isn't it? We wrote it like that, to the half. This is going to be valid for when the modulus of minus 9x is less than 1. Now, what values of x are these? Is this for? Let's just do a bit of algebra. So remember, we can separate this. This is the same as the modulus of 9 times the modulus of x, which is less than 1. The modulus of minus 9 is 9, isn't it? So this is just 9 times the modulus of x is less than 1. Now we can divide through by 9. So we're going to have the modulus of x is less than 1 over 9, right? And what does this mean? Remember, this just means that this is valid for values of x between minus a ninth and 1/9, right? So reading the question again, why is x equals minus 2 over 9 not suitable, right? It's because it's outside the range of validity. So all you're going to say is that x equals minus 2 over 9 is outside the range of validity. And that is it. And that's question 2 finished. Okay, so question 3 says f of x is equal to x plus tan a half x, where x is between pi and 3 pi over 2. Given that the equation f of x equals 0 has a single root alpha, part A says show that alpha lies in the interval between 3.6 and 3.7 for 2 marks, right? So remember, this is just very, very straightforward. You get your first mark for plugging in the 2 end points of the interval, and then you get a second mark for obviously stating that you have a change of sign. And then obviously the most critical part is stating that the function is continuous on that interval, right? Because just because you have a change of sign doesn't necessarily mean that you have a root there. It has to be continuous. So you have to write that. So for part A, all we're going to do is we're going to plug in f of 3.6 and f of 3.7. So let's plug it in and see what we get. We're going to have 3.6 plus tan of a half of 3.6, isn't it? Like that. So just put this into your calculator. Make sure calculator is in radians as well. So it's going to be 3.6 plus tan is over there, and then 1/2 of 3.6. Like that. Double checking that's all good. That looks good to me. I get negative, was that 0.686? 686, blah, blah, blah. Blah, blah, blah. Now, 3.7. 3.7 plus tan of a half of 3.7. What do we get when we put that in? So all I'm going to do, let me just go up there and edit that, to be honest. I think that's be easier. Change that to a 7, and then change that one to a 7 as well. And that gives me that number there, which is positive 0.2119. All right. So we've plugged in 3.6, we plugged in 3.7. How do we get the 2 marks? We have to state a couple of things. So the first thing is you're going to state that you have a change of sign, right? That's the first thing, right? We can see that the sign changes. And the second thing is that your function, f of x, is continuous, right? Now, it's not continuous everywhere, but it is continuous on the interval for which the function is defined, isn't it? So what we can say is that f of x is continuous on that interval, 3.6, 3.7. And now you want to just summarize what you've done. So you're going to say now, therefore, alpha lies in the interval. Right? Or I think might be better, to be fair. You could also say therefore, you could either say that, or you could say, or therefore there is a root. There is a single root alpha. Alpha in that interval. Something like that. They both would be fine, to be fair, but yeah. So again, plug in your values, state that you have a change of sign, right, which you can see, which the examiner will see. State that the function is continuous on the interval, and then write your summarize the statement. Therefore, there is a single root alpha that lies in that interval, right? So that's part A done. Part B, it says find f dash of x. So we need to differentiate now. So I'm gonna write part B here. F of x we know is equal to, was it x plus, it was tan a half x, isn't it? Yes. Tan a half x. So how do we differentiate that? Do it term by term. This is a linear term. We know that x differentiates to 1. Now this one here, we can see that we've got a composite function, don't we? Right? We've got the function of tan, but inside we've got a half x there. So this is a chain rule problem here. So how do you do this? Very, very quickly. You're going to differentiate the outer function, which is tan. Tan differentiates to sec squared. That's something you should just know. Sec squared. You can prove it using a quotient rule, but you should know it. And then we keep the argument the same, like that. And then once we've done this, we times by the inside differential, right? So we're going to differentiate the inside argument, which is differentiating a half x, which is a half. We're going to times it like that. So therefore, f dash of x is just equal to 1 plus 1/2 sec squared a half x. And that is it for part B. 2 marks in the bag. Okay, so part C says, using 3.7 as a first approximation for alpha, apply the Newton-Raphson method once to obtain a second approximation for alpha. Give your answer to 3 decimal places, and this is a 2 marker. So remember, Newton-Raphson formula, it's in the formula book, is xn plus 1 is equal to xn minus f of xn over f dash of xn. So in our case, our starting value is 3.7. So I'm going to say x1 is equal to 3.7. And obviously, this part of the formula has the function and the derivative, which is what we saw in part B. We differentiated it anyway. So we're just going to plug in 3.7 into our function, which we actually did in part A, and into our derivative, right? So let's see what that would be. It's going to be, I'll do it here. It's going to be x2, right? Which is what we're looking for. It's going to be 3.7 minus f of 3.7 over f dash of 3.7. So doing that is going to be 3.7 minus, now the function, remember, was x plus tan, a half x. Yep. So it's going to be, we did it already anyway, 3.7 plus tan of a half of 3.7, like that, over f dash of 3.7. So now I'm going to plug in 3.7 into this thing. So I'm going to just replace that. So it's going to be 1 plus a half sec squared, and then 1/2 3.7. Now, when I plug this into my calculator, I don't have sec, do I? So remember, sec squared x, we know, is 1 over cos squared x. So when I want to plug this in, I'm going to write like this. I'm going to say sec squared of 1/2 3.7 is actually the same as 1 over, and I'm going to write the squared on the outside because this is how I do it in the calculator. It's going to be 1 over cosine of a half and then 3.7. So that's what I'm going to plug into my calculator in place of in place of this one here. So let's go ahead and do that. It's going to be, I'll put this here. I don't know how much room I have. Let me zoom out a bit so you can see everything. I think that should be fine. Okie dokie. So we're plugging in this thing. So it's going to be 3.7 minus, and then fraction 3.7 plus tan of 1/2, isn't it? So I need a half like that. And then 3.7. Close bracket. So that's fine. We're going to divide this now by 1 plus 1/2, like that. And then, as I said before, I'm going to rewrite the sec squared as cos to the half 3.7 all squared. So I'm going to firstly put a bracket like that. And I'm going to get 1 over. And then I'm going to firstly put the bracket squared. So it's going to be like that. Perfect. And then I'm going to put the cosine in. So cos of a half, like that. And then 3.7, like that. And I think that's all good. Is that all good? I think I need to close the argument, don't I? I need a green bracket. Need one there. Yeah, perfect. So I think that is all good now. Oh, and I haven't closed that bracket. Close. Yeah, that looks good to me now. And then let me close that bracket on the outside as well. Okay. So yeah, that's perfect. That's perfect. If I click execute now, I get 3.672. All right. So therefore, this here is equal to, all right, x2 is equal to 3.672 because they did want it to 3 decimal places, didn't they? And yeah, that's part C finished. Okay, so question 4 says, given that y equals x squared, use differentiation from first principles to show that dy dx is equal to 2x. This is 3 marks. So remember the first principles formula. f dash of x is going to equal the lim as h tends to 0 of f of x plus h minus f of x over h. Yeah. So all you're doing is essentially just plugging everything into the formula, right? So in our case, the final f of x's, which is quite clearly x squared, what would f of x plus h be? Remember, whatever goes there, goes there. So this is x plus h, that has to be x plus h, all squared. And then now you've got everything you need, so you're good to go. So let's plug it into there. So therefore it's going to be the lim as h tends to 0 of f of x plus h, which is x plus h all squared, minus x squared over h. We need to show that that's 2x, so let's expand that. So expanding that bracket here, you can do this very quickly. You square that term, that's x squared. You square that term, that's h squared, so put that there. And then you times the two terms together. X times a h is a xh or a hx. I write hx for alphabetical order. And you put a 2. So that's 2hx plus h squared. Let me write it a bit neater. So x squared plus 2hx plus h squared, and then minus x squared over h here. So what I've done here, when I've just done that quick expansion, I've literally just used this formula. A plus b all squared is equal to a squared plus 2ab plus b squared. So all you need to do, square that one, a squared, square that one, b squared. You can see a and b, times them together to get ab, and then you double it. So that's all I've done there. Just use that formula. So now, remember, this is the lim as h goes to 0. So let me just write that as well. So lim as h goes to 0. What happens now is that those x squares cancel, don't they? Somehow. So I'm going to have a 2hx plus h squared divided by h, right? And then now remember, we could use algebra to simplify this a bit more. We could take our h from the numerator. So we're going to have h, and it's going to be 2x plus h, isn't it? Divided by h. Those cancel. Goodbye, goodbye. So therefore, we are just dealing with the lim as h tends to 0 of just 2x plus h. What happens when h tends to 0, right? X doesn't depend on h, so you're just going to be left with 2x. And that's it. Right? Or you could actually write like this just to be a bit clearer to the examiner, because h is tending to 0. You could say it's actually just 2x plus 0, because h tends to 0, which is just 2x. So yeah, that's the answer. And that is our question 4 finished. Pretty easy question, to be fair. That might be the easiest question in this paper. Okay, so question 5. The function f is defined by f of x is equal to 2x minus 3 over x squared plus 4, where x is an element of the reals. Part A says show that f dash of x is equal to ax squared plus bx plus c over x squared plus 4 all squared, where a, b, and c are constants to be found. And this is 3 marks. So, a couple of things here. They've given us f of x. They've asked to show what f dash of x is. What is the relationship between f and f dash? Differentiation, right? We need to differentiate our function. That's the first thing. Secondly, algebraically, what do we have here? We have a fraction, right? So what method of differentiation, what rule are we going to apply here? It must be the quotient rule. So whenever you're doing these types of questions, you always have to have in mind, okay, what are they asking me to do? Differentiate. Now that I know I'm differentiating, what type of rule am I going to use to differentiate it? It's quite clearly a quotient rule question. So let's get started. So part A, let me write the quotient rule. So if y is equal to u divided by v, then dy over dx is going to equal, we start with v, remember the order matters here because we're subtracting, v u dash, I put dash instead of the u because it's just faster to write, saves a couple of seconds in the exam, minus u v dash over v squared. So the problem is, sorry, not the problem, the matter of the question is identifying what u and v are. U is your numerator, v is your denominator. So u is equal to 2x minus 3. V is equal to x squared plus 4. What are the derivatives of these? U dash is going to be 2. V dash is going to be 2x, right? Very, very straightforward. So now it's just a matter of plugging them into the formula here. So we're going to do VU dash minus UV dash. So it's going to be those two. So I'll put the 2 first. I'll put the u dash first. So 2 times x squared plus 4. That is vu dash. Minus these two. So I'll put 2x first and then 2x minus 3. And then this is going to be all over v squared. V is x squared plus 4. So it's going to be x. It's going to be x squared plus 4 all to the power of 2, right? Which is good because if I look at the show that, we have that on the denominator. Now we are here. Very, very straightforward question. Remember, always have what you're trying to show at hand to compare with where you are. So we need a quadratic expression. So all we need to do is just expand and simplify the numerator. So that's going to be 2x squared plus 8 minus 4x squared plus, because there's two negatives there, plus 6x, like that. And then this is going to be all over x squared plus 4 all to the power of 2. Tidying up a bit more. 2 take away 4 is minus 2, isn't it? So it's going to be minus 2 x squared plus 6x plus 8 over x squared plus 4 all squared. And obviously they want it in the form ax squared plus bx plus c. So yeah, we're done. We're done. So a is going to equal minus 2, b is going to equal 6, and c is going to equal 8. And that is part A. Simple as that. Okay, so part B says, hence, using algebra, find the values of x for which f is decreasing. You must show each step in your work, and this is 3 marks. Okay, so remember what we did in part A. We have figured out what the derivative is. Remember, it says show that f dash of x is equal to that, and then obviously we got this expression here, right? This is the derivative, right? They've said find the values of x for which f is decreasing. Now remember what this means. If f is decreasing, it means that your gradient is negative, right? In other words, f dash of x, because we're dealing with function notation, has to be less than 0, right? So the reason why it says hence is because you have f dash of x. You did that in part A. So all we need to do to answer this question is set this less than 0 and solve this, right? Now, for what values of x would make this algebraic fraction negative? Inspect it. There are 2 parts to a fraction. You have the numerator, you have the denominator. If I inspect that denominator, right, I've got something inside, right, which is being squared, right? Now, even if I look at the thing inside, this is always bigger than 0, right? The minimum value of that is 4, right? And then I'm squaring that, right? So at minimum, it's going to be 16. But I'm saying that to say that this denominator here is always positive, right? I'm going to write here x squared plus 4, right? All squared is always positive, right? Now, the reason why I'm writing that is because of the fact I want to figure out the values of x for which this overall fraction is decreasing, is negative, right? So what I can do is I'm going to write f dash of x in terms of its sign. I'm going to write the numerator still like that, plus 6x over 8. And then I'm going to write over a positive sign just to indicate that the denominator is always positive, okay? So for this to be negative, right, less than 0, then it must come from the numerator, right? We need to find the values of x for which the numerator is negative because, remember, a negative divided by a positive is less than 0. It's a negative number. So therefore, I want the values of x for which the numerator is less than 0. So all I'm going to do now is solve minus 2x squared plus 6x plus 8 being less than 0. How do I solve that? Well, they're even. I'm going to divide by negative 2 just so I can get the x squared term to be positive. So if I divide by negative 2, it's going to be a positive x squared. It's going to be minus 3x. It's going to be minus 4. And that inequality will flip, isn't it? Right? So I'm solving this here. This is a quadratic inequality. This is very, very easy. How do we solve this? We sketch them like that. The intercept is at minus 4. I want the root, so I need to factorize that. X there, X there. What two factors of minus 4 will also add to make a negative 3? That's going to be a negative 4 and a positive 1, which means that the roots are going to be at 4 and negative 1, like that, right? So therefore, it's going to be something like this. The graph is going to look something like that, right? When is this greater than 0? It's greater than 0 for these values here, isn't it? Right? So there and there. And that are for what corresponding x values. For this side, it's when x is greater than 4. And for this side, it's when x is less than -1. So let's read the question again. It says, find the values of x for which f is decreasing. It's decreasing when the numerator is negative. The numerator is negative for values of x which are less than -1 or when x is greater than 4. So I'm just going to write f is decreasing when when x is less than -1 or x is greater than 4. And that is it. Finished. Okay, so question 6 says, figure 1 shows a sketch of the graph with the equation y equals 3 times the modulus of x minus 2 plus 5. The vertex of the graph is at the point P, shown in figure 1. Part A says, find the coordinates of P for 2 marks. So I've got this summarized here. So we want the coordinates of P, right? Which happens to be the vertex, the turning point, right? Now, whenever you're dealing with a turning point, you're dealing with a modulus problem, then all you have to do, quite simply, is just set this to 0. It kind of works the same way as a quadratic when you're completing the square, trying to find a turning point that way. So if I set that equal to 0, that means that x will equal 2, wouldn't it? Right? X minus 2 equals 0, x equals 2. And if I plug this back in, then 2 take away 2 would be 0. That would disappear, and you'd have y is equal to 5, right? So therefore, the vertex is 2, 5, right? You could even generalize it like this. You could just say, with a quadratic, you have ax minus b all squared plus c. The turning point, right, for that is going to be, you set that equal to 0 or just flip the sign, positive b. That number on the outside is c, right? It's the same thing. So modulus x minus b plus c, the turning point is going to be the same, bc. So the answer is going to be 2 there. It's going to be 5 there. And that's all you have to do for 2 marks. So that's part A. Let's go to part B. Okay, so part B says, solve the equation 16 minus 4x is equal to the modulus, or is equal to 3 times the modulus of x minus 2 plus 5 for 2 marks. So whenever I'm solving modulus questions, right, remember, if I have the modulus of anything, right, this is equal to the plus of that thing, right, or the minus of that same thing, okay? So whenever I'm solving modulus equations, right, there's always 2 cases, okay? So the first one's going to be 16 minus 4x is equal to 3 times the positive of that x minus 2. So that's just going to be like that. It's 5. That's one equation. Well, the second one is going to be 16 minus 4x is equal to 3 times the negative of that. So I'll put a minus on the outside just so it's super clear. Like that. Plus 5. Right? We're solving these 2 equations and then just seeing what x's are for both. However, whenever you're dealing with these modulus questions, you always want to consider the geometric interpretation of what it is you're dealing with and whatever equations you're dealing with, right? So remember, because of the fact that we know that we're dealing with the positive or minus of this expression here, it means that your modulus graph is always going to be 2 branches, isn't it, right? As we can see, it's always going to be a V. This part here is going to be, well, this is going up. So this is going to be the positive of it, right? So this is going to be this one here. So I'll just write 3 and then x minus 2 plus 5. That is that part there, right? And then this part in yellow is going to be the opposite, right? Now that minus on the outside, I can actually write as 2 minus x, isn't it? 2 minus x. It just looks a bit neater. So I'll write it like that instead, okay? So I'm going to write 3 bracket 2 minus x plus 5. It's the exact same thing as this. I've just expanded the minus just so it looks a bit neater. Now, why is this important? Because remember, there's a vertex, right? We know that this point here is x equals 2. So when I'm looking at the blue part of the graph, these are for values of x which are greater than 2. When I'm looking at the yellow part of the graph, these are for values of x which are less than 2. So when I'm solving these equations, I need to consider this fact here, right? Okay, so let's solve both of them and see what we get. So doing the first one, I'll do that here. 16 minus 4x, expand that 3x minus 6 plus 5, right? That is fine. And then let's tidy that up a bit. So I've got 16 minus 4x is equal to 3x minus 6 plus 5 is minus 1, isn't it? And then now I'm going to move that there. I'm going to move that there. That means 16 add 1 is 17. 3x plus a 4x is 7x. So therefore, one answer is going to be 17 divided by 7, isn't it? Right? Which is a bit more than 2, isn't it? Because 14 over 7 is 2, 17 over 7 is a bit more than 2. So that is fine, right? Because that is the blue part. That satisfies x being greater than 2. So that's not a problem. Let's do the next one. So we're going to solve this one here. So I'll do it right here. So it's going to be 16 minus 4x is equal to, now remember, we're dealing with this one. I'm going to expand that. 3 times 2 is 6. 3 times minus 6 is minus 3x, and then plus 5. Tidying that up, I'm going to move, or I'll just do it a bit neater. 16 minus 4x is going to equal minus 3x. 6 plus 5 is 11, isn't it? So that way, if I move the 11 to the left and minus 4x to the right, I'm going to have 16 minus 11 is going to equal minus 3x plus 4x. There's an x on that side. 16 take away 11 is 5. So therefore, x is equal to 5. Now, hold on a minute. Remember, what we are solving is this yellow branch, right? And we know that these are for values of x defined for x being less than 2. So that means x equals 5 cannot be a solution, right? Because it doesn't satisfy that property. So that's why it's super, super important to always remember the geometric interpretation of what you're dealing with. What values of x are defined for which part of your graphs? So what I'm going to say here is that x equals 5 is not a solution. Not a solution, since x is less than 2, right? So therefore, your only answer is going to be 17 over 7. And that's it for part B. Okay, so part C says, a line has equation y equals kx plus 4, where k is a constant. Given that L intersects y equals 3 times the modulus of x minus 2 plus 5 at 2 distinct points, part C says, find the range of values of k for 2 marks. Okay, so think about the picture, right? Whenever you're doing these types of questions, try and visualize it. We've got a line, right? Y equals kx plus 4. What do we know about this line? Well, for starters, we at least know what the y-intercept is. It's 4, isn't it? Now, what does that mean in terms of our modulus graph? Well, remember, the vertex of this point P, this was a 2 there, and that was a 5, right? So at least we know that the intercept lies below the vertex. So let's just say 4 was here, for example. Obviously, it's a sketch, right? So let's say 4 is there. Now, we're trying to find the range of values of k, right? What does k represent in the context of this line? It's the gradient, right? What happens when the gradient changes? The steepness or the slope of it changes, right? It depends on what k is, right? Either it's going to be very steep or it's going to be very flat, right? So what I'm going to do is I'm going to get a line, right? And let's just say, for example, let's just say I'll draw a line like that, right? Just to go through 4, like that, maybe. Let's see if I can. Yeah, that seems fine. Let's just say this is a horizontal line, right? What would k equals 0 be? K equals 0 would mean that there's no gradient and it's horizontal like that. So if k is changing, as we know it is, right? It would mean that this gradient would have to change, isn't it? What I'm going to do, let me move this to the left a bit so I can get the vertex to be at 4. Yeah, perfect, right? So we can see basically the gradient will pivot around 4 because we know it must go through 4. Now we need this line to cut twice. We know just by doing that, it has to be more than 0 because we need it to meet that V. So the first one is going to meet the V is going to be over there, right? So what I want to say to myself is, okay, well, right here, right, the graph, the line y equals kx plus 4 is cutting the modulus graph once at the vertex, right? Now, what will happen if I increase that gradient, right? Let's increase it a bit. We can see that it's going to cut twice now, right? Remember, it cuts once at the vertex. If I increase the gradient by going that way, it's cutting it twice, right? So what I want to do is figure out what that minimum value of k must be, right? Where it cuts the graph once, because anything above that, it will be cutting twice. How do I get that point though? Well, remember, it's very, very simple. This is 2, 5. That is 0, 4. Just do change of y over change of x. So I'm going to say m for the gradient of that line is going to be 5 take away 4, 5 minus 4 for the y's, divided by 2 take away 0. 5 take away 4 is 1, 2 take away 0 is 2. So the gradient is 1/2, right? So when k is equal to 1/2, right, the graph cuts once. So when it says find the range of values of k, we know at least it has to be more than a half. It can't be included. K equals a half can't be included because it's cutting once here. But it's a point of reference because from there, we can now say that, well, if I was to increase that gradient, it's going to cut twice. Now, it may not look like it's cutting twice, but remember, the graph continues on forever, right? We're going to keep rotating it until it gets to a point where it's not going to cut anymore. And that will happen at first when the lines are parallel, isn't it? Right? If this line is parallel to that line, they won't meet, right? So we need to now figure out what that gradient is. And that's easy. Remember, this here was y equals 3 times the positive of x minus 2 plus 5. If I expand that, that's y equals 3x, isn't it? Right? 3x minus 6 plus 5. The main thing, though, is that this gradient is 3, isn't it? So therefore, what we can say is if I get that line again, that those values of k are going to range between 3, right, when it's directly parallel and it's not intersecting, and then it's going to go down to a half, right? So essentially, we've got two parts. We've got this part here where k equals a half, and then we've got this one here when k is equal to 3. So the line ranges between a half and 3 when it cuts twice, doesn't it? So therefore, these are our two critical values. K equals 1/2, K equals 3. K equals a half when it just touches the vertex once. K equals 3 when it's directly parallel to that right-hand side of the branch. And in between those, it's cutting twice. So therefore, your values of K are going to be between a half and 3. And that's it. Finished. Okay, so question 7 says, Figure 2 shows a cylindrical tank of height 1.5 meters. Initially, the tank is full of water. The water starts to leak from a small hole at point L in the side of the tank. While the tank is leaking, the depth h meters of the water in the tank is modeled by the differential equation dh dt is equal to minus 0.12 e to the minus 0.2t, where t hours is the same off where t hours is the time after the leak starts. Using the model, show that h is equal to ae to the minus 0.2t plus b, where a and b are constants to be found for 3 marks. Okay, so firstly, we're dealing with differential equations, right? We are given dh by dt and we need h, right? So even if it wasn't even if you wasn't sure, even if it didn't explicitly say it's a differential equation, you have dh dt, you need h. How do you do that? Well, it's going the other way, isn't it? We're going to be integrating, okay? Now, because of the fact that we've got a bit of context, we've got a height, it's leaking, and so on and so forth, these are all clear indicators it's a differential equation, if it didn't say so already, but it does. Okay, so remember, when you're dealing with a differential equation, you need to separate the variables and integrate, get your plus c by using your initial conditions. So don't ever forget that. Now, with a lot of these questions, which I can see with this one, they don't always explicitly state what the initial conditions are. To be fair, I don't think any of them do now that I think of it. I think when I was doing them, they used to do it sometimes. However, there's always going to be initial conditions with these types of questions. You need to spot it. So firstly, let's actually just write this down. So we've got A here. dH by dt is equal to, what was it? Minus 0.12, isn't it? Minus 0.12 e to the minus 0.2t. What we've got to do first is separate the variables, right? So we need to get the h's together, the dt's, and the t's together. So all I'm going to do for that one is I just need to times by dt, don't I? Right? Times by dt. So that means I'm going to have the h is equal to minus 0.12 e to the minus 0.2t dt. Now the variables are separated, we can put integral signs on them like that. Then we just integrate both sides. So what I will do, I'll do this on here. So I will just copy this. Or you know what? I will just do it here so you guys can see it. So it's going to be, if I integrate dh, right? Remember, that's a 1, isn't it? That's just going to be 1h. So I'm going to have a capital H here, integrating that. And then if I integrate that over there, remember, this is an exponential. It's the reverse chain rule. So that minus 0.12 is a constant. So I'm going to write minus 0.12 times by, and then I'm going to just integrate this. Now, how do I integrate this? Remember, because we're integrating to the reverse chain rule, we're going to differentiate the power minus 0.2t differentiates to just minus 0.2. But because we're integrating, we're going to divide by it. So I'm going to do 1 over minus 0.2. And then you just multiply by the exact same thing. So e to the minus 0.2t. And then we're going to put our constant of integration. So before we look at the constant of integration, let's just tidy this up a bit. So I've got h like that, minus there and a minus there. They cancel, so it's going to be positive. 0.2 divided by that. That is 5, isn't it? 0.2. How many times 0.2 go into 1? Goes in 5 times. So it's just 5 times 0.12, which is 0.60, isn't it? So that's just 0.6. But again, you could just put this directly into your calculator. It'll be fine. And we have e to the minus 0.2 t plus c. Now we are here. We need to figure out what that constant of integration is, right? How do we do that? We need initial conditions. So remember what we're dealing with. We're dealing with a cylindrical tank, right? The water is leaking, right? As the water's leaking, time is going on. We have the height that's going to be decreasing. So the variables are going to be t and h, right? T and h is what we're looking for. This second sentence here, initially, that word there, initially, they love to use that, right? That's just another way of saying at the start. In other words, the time must be 0. So initially, this is t equals 0. The tank is full of water. Well, how tall is the tank? It's 1.5 meters, right? So if it's full of water, that means that the height must be 1.5. So essentially, this second sentence here is just a fancy way of saying when t equals 0, h equals 1.5. And that's what we're going to use for our initial conditions. So doing that, I'm going to put this here. When t is equal to 0, h is equal to 1.5. So I'm going to plug those in. It's going to be 1.5 is going to equal 0.6 e to the minus 0.2 and then times by 0 plus c. So we are here now. What are we going to do? E to the 0, because that's going to be 0, that's going to be 1, isn't it? So it's going to be 1.5 is equal to 0.6 times by 1 plus c. So 1.5 is going to equal 0.6 plus c. So therefore, move that over. 1.5 take away 0.6 is 0.9. So therefore, c equals 0.9. So now we've got c. We can now say that h is going to be equal to 0.6 e to the minus 0.2 t plus 0.9. And a and b were constants to be found, so we can say a is equal to 0.6 and b is equal to 0.9. And that is it, right? And then obviously you could always just look at the show that just to compare it. A e to the minus 0.2 tb. Yeah, so yeah, that's it. Finished. Okay, so part B says, find the time taken for the depth of the water to decrease to 1.2 meters. Give your answer in hours and minutes to the nearest minute for 3 marks. Okay, so remember, they're asking us to find the time. So that means we're looking for a value of t, right? For the depth of the water to decrease to 1.2. 1.2 is a height, right? So we are looking for the time t when the height is 1.2. Remember, it starts at 1.5. We want to find out what the time is when it's 1.2. So all we're going to do here is say we're looking for t when h is equal to 1.2. So that means we can replace that with 1.2. And then we have 1.2 is equal to 0.6 e to the minus 0.2 t plus 0.9. So it's just a matter of solving that. First, I'm going to take away that 0.9. Like that. So that means if I move that over, that's going to be 0.3, isn't it? So it'll be 0.3 is equal to 0.6 e to the minus 0.2 t. I'm going to divide by that now, aren't I? So I'm going to have 0.3 divided by 0.6 is equal to minus 0.2 t. Now 0.3 over 0.6, that's just a half, isn't it? Right? So therefore, I can actually write this as minus, as e to the negative 0.2 t is equal to 1/2. Now remember, we're trying to figure out what t is. We've got an exponential. We need to get rid of this. We do this by doing the opposite of e's, which are taking ln's. So we need to take the ln of both sides. So when I take the ln of both sides, that will cancel. It'll be minus 0.2 t is equal to the ln of 1/2. And then now we can get t. To be fair, I like writing fractions. So 0.2 is a fifth. So I can write this as minus a fifth t is equal to ln of 1/2, which means now I'm just times it by minus 5, isn't it? But that's the same as dividing that by minus 0.2, but I just like to write it as fraction. So it's going to be minus 5 ln of 1/2. So this is our answer here. However, they did say give your answer in hours and minutes to the nearest minute. So this is no good. So we need to just put this into our calculator just to see where it is roughly. So minus 5 ln, which is over there, 1/2. is 3.46 something. So therefore, it's going to be 3.465 hours, right? So it's going to be 3 hours and a bit. Just under 3.5, isn't it? So 3 hours. And that 0.465 is 0.465 hours. So what I'm going to do is convert that into minutes, aren't I? So get my calculator. Let me get rid of that 3 by taking it away. So I'm going to do answer, shift answer minus 3. That will isolate the decimal part of it. And then now this is in hours. I want it in minutes, don't I? To go from hours to minutes, you times by 60. So I'm just going to do answer times by 60. And that gives me 27.944, right? So therefore, that is, times that by 60, that's 27.944 minutes. So it's 3 hours and 27.944 minutes. They wanted it to the nearest minute, isn't it? So that's just going to be 28. So therefore, your answer is going to be 3 hours and 28 minutes. And that is it for part B. Now let's do part C. Where is part C? There. In the long term, the water level in the tank falls to the same height as the hole. Find, according to the model, the height of the hole from the bottom of the tank. So let's look at the diagram again. The hole is there. It would make sense that it would fall there because there's going to be no water coming out underneath that hole, isn't it? So it's going to go there. So we need to figure out what that height is. Now, they've used a very key term here. It says in the long term. When I look at that phrase long term, that just tells me as t tends to infinity, right? So in other words, what is h as t gets extremely large in the long term, right? So let's refer to our model here. Where are we? We did part B here. I'll grab this. I'll grab this here, copy, and I'll do it here, to be honest. Why not? So we want to figure out part C. What happens as t gets really, really big? So let me write that. What happens as t gets stupendously big? There's a couple ways to do this. You can either punch in a really, really big number into your calculator and you'll get the answer. But I think I like it when you do it algebraically. It's more elegant. So the reason what I'm going to do is I'm going to, that minus there, that tells me I can actually write this as 0.6 divided by e to the 0.2t and then plus 0.9, like that. What happens as t gets really big here, right? This denominator is going to be massive, isn't it? Right? It's going to get really, really, really big. So essentially what will happen is that you're going to have h is equal to 0.6 over something which is essentially going to tend to infinity, right? Plus 0.9. 0.6 divided by a very, very big number is just 0, essentially, right? It's going to go to 0. So essentially, h is just going to equal 0.9 as t gets really, really big. So your answer is going to be h is equal to 0.9 meters. And that is it. Again, as I said before, you could just plug in a really, really big number into your calculator and it will do the job for you. So let's just say, for example, you can try it your own. Plug in 0.6 e to the minus 0.2 times, I don't know, 10 to the power of 10 plus 0.9. It will give you 0.9 as well. So yeah, that is it for question 7. Okay, so question 8 says the functions f and g are defined by f of x is equal to 4 minus 3x squared, or x is an element of the reals. G of x is equal to 5 over 2x minus 9, where x is an element of the reals and x cannot equal 9 over 2. So this denominator can't be 0 essentially. Part A says find f of g of 2. So remember, this is just a composite function. We're going to plug 2 into g first. Once we get that, we're going to plug it into f. So let's do that here. So part A, we're going to figure out what g of 2 is, right? G of 2, we're going to plug 2 into that. So it's going to be 5 over 2 lots of 2 minus 9. 5 over 4 take away 9. 5 over minus 5, which is minus 1, isn't it? Right? So that is going to be g of 2. And then now we need to plug that into f. So f of g of 2, I'll put another bracket around here, is the exact same as f of minus 1. So what is that equal to? 4 take away 3 minus 1 all squared. 4 take away 3 minus 1 all squared. That is 4 minus 3. Minus 1 all squared is a positive 1. That's 4 take away 3, which is 1. So therefore, f of g of 2 is just 1. So that's part A. Part B, it says find the inverse of g. So the inverse of g. Okay, so part B, we need the inverse of g. What is g of x equal to though? G of x is equal to 5 over 2x minus 9. 5 over 2x minus 9. So to find the inverse, just replace that with a y. So I'm going to set it, I'll do it here. Say y is equal to 5 over 2x minus 9. And then we interchange x and y. So I'm going to say x is equal to 5 over 2y minus 9. And then our job is to make y the subject. Whatever we get for y when we make it the subject is going to be our answer for the inverse of g. So firstly, what I'm going to do for the next step is I'm going to times both sides by 2y minus 9. So the next step will be x bracket 2y minus 9 is equal to 5. I'm going to expand that. So it's going to be 2xy minus 9x is equal to 5. And remember, we want y on its own. So what I'm going to do now is I'm going to add on the 9x, aren't I? So the next step will be 2xy is equal to 5 add 9x. And then now we're going to divide by 2x, isn't it? So y will equal 5 plus 9 divided by 2x. Now that we've got y as the subject, we just replace that with g. So therefore, your answer to part B is just going to be g inverse of x is going to equal that expression there. I forgot the x here, didn't I? 5 plus 9x, sorry. So 5 plus 9x over 2x. And that is it. Now, remember, whenever you're dealing with these questions, right, if they ask you for the inverse, you should always state the domain as well. So when I look at this expression here, the domain of the inverse is going to be the range of the original, isn't it? So what's the range of this function? It's a rational function. What happens as x gets really big? As x gets really, really big, this is just going to tend to 0, isn't it? We can't put 9 over 2 in. So the only value that doesn't work, right, or that you cannot get, right, in terms of a y coordinate, a y value is going to be 0, right? You can't set this equal to 0 and get a value out, right? So that is the only value of y that won't work. So what I can say then is that the range, I'll do it here, the range of g of x, right, is just going to be g of x is going to be element of the rows. It could be anything but 0, right? That is the range of g of x. Remember, we want the domain of the inverse to complete the inverse function. So we just need to swap this over. So I'm going to say then that the domain of the inverse, right, is just going to be, remember domain with inputs, we're going to use x now. It's just going to be x as an element of the rows, right? But x can't be 0, right? So every x value other than 0 will work. So therefore, I'm going to just put this there. So to finish off, I'm going to say x is an element of the rows, and x can't equal 0. And that will give you all of the marks. Was part B 3 marks? Yeah, it was. You get the last mark for defining the domain of it. So yeah, that's it. Finished. Okay, so part CI, find g of f of x, given your answer as a simplified fraction. So g of f of x, f is going into g, isn't it? So I'll do it here. So I'll put I here. F is going into g. So that means that g of f of x is going to equal, g is 5 over 2x minus 9. So 2, and I'm going to leave that here, and then minus 9, like that. But remember, our input is now f of x. So I'm going to put 4 minus 3x squared in, aren't I? So it's going to be 4 minus 3x squared, like that. Let me just make this a bit neater. So like that, close bracket minus 9. We need it as a simplified fraction, so let's expand the denominator. So that's going to be 5 over 8 minus 6x squared minus 9, which is going to be 5 over, I'll put the minus 6x squared first, and then 8 minus 9 is minus 1. So that is our answer here. Or what I like to do, just so it looks neater, I'm going to put the minus, we could take out the minus like that. 6x squared plus 1. We can do that. And then that minus I can actually put on the outside of the function as well. So I'm going to say then that g of f of x is equal to minus and then 5 over 6x squared plus 1. Just looks a bit neater that way. Okay, so that is our answer for part I. Double I, which is a bit trickier, it says deduce the range of g of f of x. Now, whenever I'm trying to find the range of a function, right, I always visualize it, right? Now, why do I do that? Remember, if you're trying to find the range of a function, you look up or down. What are the y values it could take? If you're trying to find the domain, it's left or right. What are the x values it could take? So if I can successfully sketch this graph, then it will be easy for me to figure out what the range is. I just look up and down. What is the maximum? What is the minimum? That's it. So, firstly, how do I sketch this graph? Well, it's a rational function. If I inspect the numerator is a constant 5. There is no variables. There are no x terms in the numerator, which means immediately that it can never equal 0, right? So 5 over 6 squared plus 1 with the minus in front. This cannot equal 0. I cannot solve this equation for a value of x that will satisfy it. It doesn't work, right? So immediately that tells me that there's a horizontal asymptote at y equals 0, which is the x-axis. So I'm going to get a sketch going. Right? Like that, right? And I know that the x-axis, whoops, we put y here, x here. The x-axis, which is the same as y equals 0, is a horizontal asymptote to this graph here. Now, let's actually sketch the graph. What I'm going to do is I'm going to ignore the minus at the front for now. I'm going to just sketch this. 5 over 6x squared plus 1. I know there's an asymptote on the x-axis. What does this look like though? If you just inspect the denominator only, that is 6x squared plus 1. What does that look like? Well, that's easy. That's a quadratic, right? It looks like that, right? Starts at 0, but the plus 1 means it goes up. So the minimum value is 1. And for me, what that tells me is that when x is not 0, right, this graph is always increasing, right? It's increasing for values of x that are positive, increasing for values of x that are negative, which tells me that when I translate that to this overall function here, as x increases on the denominator is always going to increase as well. So the fraction overall is going to get smaller and smaller. So what I can say here is I'll do it here. So as x tends to infinity, 5 over 6x squared plus 1 will tend to 0, isn't it? Right? And because of the fact that I'm squaring the input, right, it will be the exact same for negative infinity as well. As x tends to negative infinity, 5 over 6x squared plus 1 will also tend to 0. So in both directions, as x gets big, as x gets very negative, right, the graph will tend to 0, which means, technically speaking, right, the graph is going to be symmetrical. So it's going to start at a maximum value and then it's just going to work its way down, right? Not until we get to 0, because we'll never get there, but it's going to get very close. And because of the fact that the negative x values will give me the same output, right? It will be symmetrical like that. So the graph is going to look like that. So the question now is, well, what is that maximum value? Well, it's clearly when x equals 0, isn't it, right? So plug in x equals 0, you're going to have 5 over 6 lots of 0 squared plus 1, which is 5 over 1, which is 5. So therefore, that maximum value is 5, right? Now, this is what the graph looks like. This is not the graph we want though, because we forgot the minus, didn't we? Right? So now that I know that this is this graph, when I have the minus, well, what does that do to the graph? It just reflects it in the x-axis, doesn't it? So the graph that we want, g of f of x, is actually like this. Like that, right? And now that minimum value now is going to be negative 5, right? So we've sketched the graph. What is the range? Remember, we said the range is looking up or down. So I can see that the minimum value here, quite clearly, right, is going to be at y equals minus 5, for sure. The maximum, well, it never actually gets there, but it gets very close to the x-axis. It never actually gets to 0, but it approaches it. So I'm going to say y equals 0 is going to be the top, right? So the graph ranges between these two values, as we can see quite clearly, right? When you visualize the graph, it's easy, okay? So then, therefore, we can now say that the range, right? I'll do it here. The range of g of f of x, right, is just literally equal to, right here, g of f of x, right? We can see quite clearly that the minimum value is minus 5. That's included. The maximum, right, which is not included, is the horizontal asymptote, the x-axis, y equals 0. So the range of g of f of x is between minus 5 and 0. And that's it. Okay, so part D. The function h is defined by h of x is equal to 2x squared minus 6x plus k, where x is an element of the rules, where k is a constant. Part D says find the range of values of k for which the equation f of x is equal to h of x has no real solutions for 3 marks. Okay, so immediately, first thing we're going to do is obviously get the equation that we need. So part D, I'll put here. F of x is equal to h of x. I put f of x here because that's what we need. So it's going to be 4 minus 3x squared is equal to h of x, which is 2x squared minus 6x plus k. That's going to be your first line. Now we need to find the values of k, the range of values of k, for which there are no real solutions. Couple of things here, right? Find the range of values, right? Whenever you see find the range of values, that means that you're solving an inequality. So your answer is going to be an inequality, right? Secondly, what are you dealing with? You've got quadratic expressions on both sides. This is a quadratic equation. How do you determine the number of solutions when you're dealing with quadratics? It's the discriminant, right? So what you're going to do is get it into a nice format, ax squared plus bx plus c, apply the discriminant, and because there are no real solutions, it means that the discriminant is less than 0, isn't it? So let's do that. I'm going to do everything from left to right just so we can get the quadratic term to be positive. So I'm going to have 0 is equal to, if I move the 4 over, then it's going to be 2x squared minus 6x plus k plus the 4. Sorry, not plus the 4, minus 4, isn't it? Because I'm taking it away. So I'm going to take away the 4, so minus 4, and then I'm going to add on the 3x squared like that. So that means then that 2 plus 3 is 5, 5x squared minus 6x plus k minus 4, isn't it? And this has to equal 0. This is our quadratic. Since there are no real solutions, all right here, no real solutions means that b squared minus 4ac is less than 0. So therefore, let's apply the discriminant. A is going to equal 5 right there. B is going to equal minus 6 right there. Now, C, remember, K is a constant. So K minus 4 is just a constant as well. So C is going to equal K minus 4. So therefore, it's going to be minus 6 all squared, minus 4 lots of 5 times by K minus 4. And that's going to be less than 0. So that's 36. 4 5s are 20. So if I expand that, that's going to be minus, or I'll do it a bit. 20K minus 4. Why not? Less than 0. 36 minus 20k plus 80 is less than 0. So that must mean then that what is that 80 plus 36 is 116. Is that correct? Yes. Yeah, 116. So minus 20k plus 116 is less than 0. So that must mean then that let me times by minus 1 so I get on, let's say, so I can put the k on the left. Times by minus 1 is going to be positive 20k minus 116. I'm going to flip that inequality now, aren't I? So it's going to be 20k is going to be greater than 116. That must mean that k is going to be greater than 116 over 20. What's half of 116? 58. Yeah, 58. Divide that by 10 is going to be 5.8. So that right there is 5.8, isn't it? Or next question, I'll do it here. Yeah. So the answer is going to be k is greater than 5.8 or 58 over 10, which is the same as 29 over 5. Is that correct? Yeah. Yeah. So either one of these. Perfect. That's it. Okay, so question 9 says the first three terms of a geometric sequence are 3 to the 4k minus 5, 9 to the 7 minus 2k, and 3 to the power of 2 times k minus 1, where k is a constant. Part A says using algebra and making your reasoning clear, prove that k is equal to 5 over 2 for 3 marks. Now, whenever you see these types of questions whereby you've got the first couple of terms of a geometric sequence given to you, algebraically, what you always want to do is form expressions for your common ratio, right? Because we've got three terms there. Remember, the common ratio is always one of the terms divided by the term that precedes it, the term before it. So because we've got three, we could find two ways. This is a very common question as well because I've seen it come up a couple of times. It came up in paper 2, question 15 of June 2022. So definitely have a look at that question. It was a trigonometric question where they had theta. You had the first couple of terms with sine and cosine, and then you had to use your identities to show that you get a certain equation, something like that. But definitely have a look at that. So let's get started. So part A, now the common ratio, as we said before, is going to be one of the terms divided by the term before it. So we could say, I'm going to say R is going to equal the second term divided by the first term, divided by the first term, and it's also going to be equal to the third term divided by the second term, isn't it? So with that being said, then I can say that R, right, which is going to equal 9 to the power of 7 minus 2k divided by 3 to the power of 4k minus 5 has to be equal to 3 to the power of 2k minus 1, third term, divided by 9 to the power of 7 minus 2k, the second term. Okay, so we are here. We need to prove that k equals 5 over 2. So we just need to solve this equation. Now, what I'm going to do is I'll get rid of the r for now because we've got the equation. We're just solving this. I'm going to cross multiply. So I'm going to have, if I times that up there and then that up there, that will be 9 to the power of 7 minus 2k. It's going to be squared, isn't it? So I'll put a square like that. And then this will equal 3 to the power of 2. And then, I'll expand it after 2k minus 1 multiplied by 3 to the power of 4k minus 5. Like that. So we just cross multiplied. Now we're trying to find out what k is. The algebraic terms are in the powers, aren't they? So this is an exponential equation. And what you want to do, this is actually the GCSE technique, right? You just want to make sure that the bases are the same so you can equate the powers, okay? So I'm going to just tidy this up a bit. Now, remember this one here, right? That one there. This is a power of a power. A to the B, all to the power of C is A to the BC. So I can times these two. So that means that I'm going to have 9 to the power of, and then times those. That's going to be 2 sevens are 14. 2 times 2k is a 4k. So I'm going to have minus 4k like that. And then this will equal, let me expand that. So that's going to be 3 to the power of 2k minus 2 times by 3 to the power of 4k minus 5. Okay, so we are here. Now, remember what we want to do. We want the bases to be the same. That way we can equate the powers. So firstly, what I'm going to do is I'm going to combine these. Remember, these have the same base, so we know that we can add the powers. So it's going to be 3 to the power of 2k minus 2 add 4k minus 5. That's that side. Now, the left-hand side, remember, 9 is the same as 3 squared. So I can actually write this as 3 to the power of 2 all to the power of 14 minus 4k. Now I'm here. Let's tidy this up a bit. So we have a power to another power. So we're going to times them. So it's going to be 3 to the power of 2 times 14 is 28. 2 times 4 is 8. So I'm going to have minus 8k there. And this will equal, now we can just add these. So it's going to be 3 to the power of 2k plus a 4k is a 6k. Minus 2 minus 5 is a minus 7. So I'm here. Now, since the bases are the same, right? That means we can just equate the powers. 3 to the power of something is equal to 3 to the power of something else. It must mean that the powers have to be the same. There's no other choice. The two powers must be the same for this equation to hold. So I'm going to equate them. So I'm going to say 28 minus 8k has to equal 6k minus 7. So that way, I'm going to move that there, move that there. That means I'm going to have 28 plus 7 is going to equal 6k plus 8k. 28 plus 7 is 35. 6 plus 8 is 14. So I have 40k on the left, on the right, which means that k is going to equal, divide both sides by 14. 35 divided by 14. We could divide top and bottom by 7, can't we? 35 over 7 is 5. 14 over 7 is 2. So therefore, k is equal to 5 divided by 2. And that is it. That is part A finished. So again, whenever you see these types of questions, get an expression for your common ratio, equate them, solve. That's it. Okay, so part B, it says, hence find the sum to infinity of the geometric sequence for 3 marks. So immediately, sum to infinity, I will start by writing the formula. Sum to infinity is a over 1 minus r, right? A is the first term, r is the common ratio. So for us to answer the question, we need to figure out what a and r are. Now, since we know that k equals 5 over 2, right? We can plug this into our expressions to get the first term and to get the common ratio. So let's get the common ratio again. Remember, common ratio is the second divided by the first term, or the third divided by the second. Doesn't matter which one you use, it's going to be the same thing. I'll just use the second term, 9 to the 7 minus 2k over 3 to the 4k minus 5. Now, since we know that k equals 5 over 2, I can use that to figure out what the common ratio will be. So I'm going to plug that in. So it's going to be 9 to the 7 minus 2 over 5 over 2 divided by 3 to the 4 and then 5 over 2 there and then minus 5. So I'll put that into my calculator and that will give me the common ratio, wouldn't it? So putting that in is going to be fraction bar 9 to the 7 minus that is just 5 to be honest, but I'm just going to put it in just so it's like clear and stuff. So 5 over 2, I'll just put it in like that. Like that, and then that is 3 to the 4 and then 5 over 2. So 4 and then 5 over 2 like that, and then minus 5. So that is all good. That looks good to me. Perfect. That is equal to a third. So the common ratio is a third. Okay. Now we need the first term. So the first term is going to be found by plugging in 5 over 2 into this one here. So I'll do that here. So it's going to be 3 to the power of 4 to the 5 over 2 and then minus 5. That is equal to 243, right? So therefore, I'm going to say A is going to equal 3 to the 4, 5 over 2 minus 5. So A is equal to 243. So therefore, the sum to infinity is going to be A, which is 243, over 1 minus a third, right? Which is equal to 243 over 2/3. Is that correct? 3 over 3, yeah, 2/3. Times that by 3 divided by 2. I don't know what that is, so I'm going to put it in the calculator. So it's going to be 243 divided by, and then 2/3, like that. That is 729 divided by 2. And that is your answer for part B. Finished. Okay, so question 10 says, figure 3 shows a sketch of part of the curve of the equation y equals 8x minus 8 minus x to the 5 over 2, where x is greater than or equal to 0. The curve crosses the x-axis at the point A. Verify that the x coordinate of A is 4 for 1 mark. That is part A. So I've just got that summarized here. Now, it's a 1 marker and it says verify. My teacher, when I was in sixth form, always told me the difference. When you see verify, that's just substitution, plug in a value. Show that means you have to use algebra to get to your value. So in this case, you don't have to make this equal to 0 and then use algebra to show that x is 4 or anything like that. You just literally sub in x equals 4 and show that y is equal to 0 because it crosses the x-axis. So that's all you need to do for part A. So I'll do that now. So for part A, we're just going to plug in 4. So 8 times by 4 minus 4 to the 5 over 2. What's that? So that is equal to 8 fours are 32. That right there, you can put this into a calculator, but that is the square root of 4 all to the power of 5. That is 2 to the 5, which is 32. So it's 32 minus 32, which is equal to 0, right? So therefore, the x-coordinate of A, x-coord of A is 4. Perfect. That's part A. Part B, it says the line L1 is the tangent to the curve at A. Use calculus to show that an equation of line L1 is 2x plus y is equal to 48 for 3 marks. So the equation of a tangent, right? Remember, if you're trying to find the equation of a tangent, which is a line, just get the general formula. So y minus y1 is equal to mx minus x1, right? Remember where x1 and y1 is a point in question and m is your gradient. So what do I need to figure out? Well, we know what the point is. It says the line L1 is a tangent to the curve at A. We know that the point A is 0, 4. No, 4, 0 actually, because we plugged in 4, we got y is 0. So other way around, 4, 0. So that's going to be our point. Now we need the gradient. We're dealing with a curve. How do you find the gradient of a curve? You have to differentiate, okay? So let's write out what y is. Y is equal to 8x minus x to the 5/2. So we need to differentiate this, don't we? So differentiating that will be dy over dx will equal that will just go to 8 minus, bring the power to the front, that's 5/2. So 5 over 2, right, a bit neater. 5 over 2x, and then you take 1 away, so that's going to be 3 over 2, isn't it? So this is going to be our gradient function. Now we need the gradient of the tangent. You do that just by substituting your x value into your d by dx. So we're going to plug in x equals 4 into there. So let's say x equals 4. dy dx is going to equal 8 minus 5 over 2, 4, 3 over 2, isn't it? I think I can do that without a calculator. 8 minus 5/2. Square root of 4 is 2. 2 cubed is 8. So that's going to be 8 right there, isn't it? 8 divided by 2 is 4. 5 fours are 20. This is 8 minus 20, which is minus 12. So the gradient is minus 12, right? Now that's a negative gradient. Let's look at the graph again. It says L1, right? L1, as you can see, is going downwards. So we do expect that gradient to be less than 0. So these are the type of things that you could be doing just to check that you're on the right track, okay? L1's going down, gradient's negative, which it is, it's minus 12. So now we've got everything that we need to answer the question. So again, we have m is equal to minus 12. We've got the point x1, y1, which is 4, 0. So now we're just going to plug it into y minus y1. So it's going to be y minus 0 is going to equal m, which is the gradient, minus 12, x minus 4. So doing that, y minus 0 is just y. That is going to be minus 12x plus 48, isn't it? Yes, 48. What form do they want it in? 12x plus y is equal to 48. So we move the minus 12x to the left, don't we? So add on 12x there, and then we get what they want. So 12x plus y is equal to 48. Let's just double check. Yeah, that's it. So that's it. 3 marks in the bag. Done. Okay, so part C. The line L2 has equation y equals ax. The region R, shown shaded in figure 3, is bounded by the curve, the line L1 and the line L2. Part C says use algebraic integration to find the exact area of R for 5 marks. Okay, so the area of R is shaded, right? Now, whenever I'm doing these types of questions where I'm trying to figure out an area that is shaded, I'd always break down the actual shaded area itself to figure out how I actually calculate it. Now, remember, to calculate majority of the time to calculate a shaded area, you're not using a formula to directly calculate that shaded part. It's literally taking one area away from another, right? So when I look at this, that area R, right? So I'm going to draw something like this. Hopefully I don't butcher it too much. Something like that, essentially, right? How would I calculate that area? Well, when I look at it, that area R happens to be a portion of the area of that triangle, isn't it? So what I can do is let me get a triangle going. I'll get a triangle going, something like this there, like that. And then I would take away the area of this thing, isn't it? Right? That little quote unquote semicircle. It's not a semicircle because it's a curve, but you know what I'm saying. So the answer to the question for the area R is to calculate the area of that triangle, calculate that area of that semicircle, and that will be the answer. So the question is, how do we work those out? So I've got the graph and I've got the lines that we know. So remember, we know that line L1 was 12x plus y is equal to 48. That's fine. They did tell us that L2 is y equals ax. So that's over here, like that. Okay. What do we need to do? So let's figure out the dimensions of this triangle. Now, the dimensions, we need the base, right? And we need that perpendicular height, don't we? Now, the base is very straightforward. Remember, this is the origin to A. We know that that coordinate there is a 4, 0. So that width is 4, isn't it? So at least we know what the base is. The base is 4. How do I calculate the height? Well, if you look at it, right, the two sides of the triangle are actually just the lines L1 and L2. So what I can do is say, well, that point of intersection there, right, if I drop a vertical line down there, like that, that would give me the x coordinate of that point of intersection. If I know that x coordinate, I can figure out the y, and that y coordinate is going to give us the height of this triangle, isn't it? So that's what I need to do. I need to figure out the point of intersection, right? L2 and L1 we know. So let's write them here. So we know that L1 is equal to 12x plus y is equal to 48. Let me put a colon here. Like that. L2 is y equals 8x. We need to solve these simultaneously, don't we? We could do this any way we like. Y equals 8x is probably just best to just sub that in there, isn't it? So solving that simultaneously, I'm going to have 12x plus y, which is 8x, is going to equal 48. 12 plus 8 is 20. So 20x is equal to 48. That means that x is going to equal 48 divided by 20, which is 24 divided by 10, which is 2.4, isn't it? Or 12 over 5, like that. Divide by 4. I don't know why I didn't just do that. So I know that x is 12 over 5, right? I want to figure out what y is because that will give me the height. So I can now plug that into either one of these, but it's obviously easier to plug it into y equals 8x. So I'm plugging in x equals 12 over 5 into y equals 8x to get the y coordinate, which is going to be the height of this triangle. So it's going to be 8 times by 12 divided by 5. What's that? Let me just put it in my calculator. 8 times 12 over 5 is equal to 96 over 5. So y is equal to 96 divided by 5. What is that as a decimal? Just for context, it's 19.2. Okay? Okay, so we now know the dimensions of this triangle, right? Remember, this is 19.2 or 96 over 5. So I can put that there. So therefore the area, right? So I'll do it here. The area of this, remember this is a triangle, it's just half times base times height, isn't it? Half times the 4 times the height, 19.2. I'll put it into the calculator and see what we get. So 1/2 times by 4 times by 19.2. That is equal to 38.4. So the area of this triangle is 38.4, isn't it? I'll put that in a circle. That area is 38.4. Now I need the area of this quote unquote semicircle, right? Now remember that area is bounded by the x-axis and the curve, right? So how do I find out that area? Remember the question did say use algebraic integration. We haven't integrated yet. The area underneath a curve bounded by the x-axis is just definite integration. So all I need to do is integrate our function ax minus x to the 5 over 2 between the limits of integration, which in this case is going to be between 0 and 4. Okay, so I'm going to do that on this page here. So I'm going to say this area here, which is what we're looking for, which is between 0 and 4, is just going to be equal to the integral of the function, the curve, ax minus x to the 5 over 2 dx between 0 and 4. Let me just make sure I've written it down correctly. Yes, I have x to the 5 over 2. Yes, I have. Perfect. So how do we integrate? We add 1 to the power, divide by the new power. So it's going to be that 8 is a constant. X, add 1 to the power 2 divided by 2. And then minus, and then we're going to add 1 to that power. So it's going to be x to the 7 over 2 divided by 7 over 2. And this is between 0 and 4. So let me just tidy that up a bit. So that's going to be 8 divided by 2 is 4. So 4x squared. Divided by 7 over 2 is the same as times it by 2 over 7, isn't it? So it'll be minus 2/7 and then x to the 7 over 2 between 0 and 4. So now I just need to evaluate those limits. So it's going to be 4 times 4 squared minus 2 over 7, 4 to the 7 over 2. And then that will be taken away the lower limit, which is just going to be 0, isn't it? But I'll just put it in like that anyway. 2 over 7 and then 0 to the 7 over 2, like that. Yeah, that's fine. So I know for sure that that is 0, isn't it? Right? Don't even need to put it in the calculator. Putting that into the calculator, let me do that. So what do we get? So we're going to have 4 times 4 squared minus 2/7 of 4 to the 7 over 2. Like that. Let me just double check. Yep. That's good. Execute 192 over 7. So this area here, so this answer is 192 over 7, right? Which is the area. I'll do it here. 192 over 7 minus 0 is 192 over 7. This is the area of this thing. 192 over 7, right? And that is that thing there, 192 over 7. So therefore, the area of that region R is going to be 38.4 minus 192 over 7, isn't it? So I'll do that here. So I'm going to say, therefore, the area of R is going to equal 38.4, the area of the triangle, minus the area of that quote-unquote semicircle. How many times have I said that today? I need a counter. Like that. So put it into the calculator, see what you get. So I'll do it here. So 38.4 minus 192 divided by 7 is equal to that there. Does it give it to me as a fraction? 384 over 35. Perfect. 384 over 35 square units. And that is it. That is question 10 finished. Okay, so question 11. Figure 4 shows the design of a badge. The shape ABCOA is a semicircle with center O and diameter 10 centimeters. OB is the arc of a circle with center A and radius 5 centimeters. The region R, shown shaded in figure 4, is bounded by the arc OB, the arc BC, and the line OC. Find the exact area of R. Give your answer in the form a root 3 plus b pi centimeter squared, where a and b are rational numbers, and this is a 4 marker. So this one here, again, we're looking for a shaded area. So what I always do, just like we did in question 10, is you always want to map out the actual area that it is you're trying to find. Remember, most of the time you're doing shaded areas, you're not finding it directly. You're subtracting one area from another area, okay? So the first thing that I would do is say to myself, okay, well, let me just zoom out a bit. I'd say, well, okay, that region R, right, which looks something like that, right? Call this R. This is going to be equal to the entire semicircle, isn't it? So I'll just draw a semicircle like that, right? And then this is A, and then this is C, and then that's B over there. And I'm going to take away that area ABO, this area here. So it's going to be something like that. So this way, you say to yourself, okay, well, fine. If I can work out both of these areas, subtract them, then I'm done. So let's work these out. Now, what do we know? We know that the shape, the semicircle, has a center O, right? The center's here at O. The diameter is 10. The diameter is 10. That means that the radius is 5, right? Which means that we can just work out the area, pi r squared divided by 2, isn't it? Because it's a semicircle. So I'll do this here. That's going to be pi 5 squared divided by 2, right? Which we can write as 25 pi over 2. So that is the area of the semicircle, right? So that is pretty straightforward. The difficulty is obviously calculating what this area is on the right, ABO. So what I've done is I've actually got the diagram here again. We're going to just annotate it a bit as we go along. So what do we know? We know that the center of the semicircle is O, right? So that's O over there. Now, if you think about it, since we know this is the center and the diameter is 10, right? Then obviously any point from the center to the circumference is going to be the radius, right? So what I can do is I can say, well, for example, that over there, if I just draw a dotted line like that, that has to have a distance of 5, isn't it? Like that. And then again, from O to A, which you've already seen, that has to be 5 too. So we know that those are 5. Now, let's have a look at the information again. They've also told us that OB is the arc of a circle with center A and radius 5 centimeters. How does that help us? OB, right? OB is obviously this here, right? They said that it's an arc, right, with a center of A. The center A is here. The point A is there. If this is the center and that's the arc, and they've told us that the radius is 5 centimeters, right? Then that means that this distance, A to B, over there, this is also 5, isn't it? So what do we have here? We've got an each equilateral triangle, which means that each angle is 60 degrees. But we're dealing with pi, so I'm going to do it in radians, right? So this angle here, and this angle here, they're all the same, right? We know that pi is equal to 180. So 60 degrees is going to be pi divided by 3, isn't it? So these are all pi over 3, like that. Okay. Now, how is that helpful to us? Remember, what we're trying to do at the end of the day is work out the entire area. Okay. This is helpful because of the fact, since we know that this angle here, right? I'll do it in a different color. This angle is pi over 3. It will actually allow us to work out the area of this sector. I'll do it in green. This sector over here can actually work out the area of this entire sector. And once I know that area of that entire sector, that will allow me to calculate that smaller segment, but I'll do it bit by bit. So let's work out what that sector is. I'll draw it out again. So I'll do it here. So that sector ABO, which I'll draw like that, that's going to be pi over 3. We know that this is 5, that's 5, right? Remember, the area of a sector is a half r squared theta. So therefore, it's going to be area of sector, that's going to equal 1/2. The radius is 5, so 5 squared. And then theta is pi over 3, isn't it? So that being said, that is going to be 25 divided by, I'll do it like this. We've got 1 times 5 squared is 25 times by pi over the denominator is 2 and 3. 2 times 3. That is just going to be 25 pi divided by 6. Okay. So we know that this area here is 25 pi divided by 6. That is the area of that sector, right? Now, that sector is pretty much the majority of that area ABO, which is what we're looking for. However, it's not the entire thing, is it? What we need to work out now is this little section here, this little area here, right? If I could work out this area in blue, add it onto the sector, then that will give me that entire area, wouldn't it? Now, how do I find out that area in blue? Well, that's where the triangle comes in, right? Because if you think about it, right, if I find the area of that triangle and I subtract the area of the sector, it will leave me with either one of those sectors, right? It will leave me with either one of this little one here or that one here, because it's the same thing, isn't it? So what I'm going to do, I'll do it on this page here. So that little area there, this is going to be equal to the area of that sector, right? Which we know is 25, what was it? 25 pi over 6. And then we would take away the area of the triangle, like that. And we know that this is 5, 5, 5, and that's pi over 3, isn't it? Okay, these are all pi over 3s. Now, the way I've written it, that area is it's actually going to be this one I'm finding, but it's the same thing. So let me draw a dashed line like this. So dashed line like that, right? If I just do it this way, like that. So that area there, right, is equal to the area of the entire sector minus the triangle. But that is the exact same thing as doing it on the other side, isn't it? So I'll show you. So this area in blue and that area there, that is the exact same thing, right? So I'll just do it here just so it's super clear. So that area, like that, is going to equal the area of this sector again. So I'm just doing it the other way now. Remember, because that angle is still pi over 3, right? Because it's that one in the triangle. That is a 5, that is a 5. So it's the exact same thing, okay? Just in case it wasn't clear. And then we're taking away that triangle. Do it again. I just realized I can actually draw a triangle like that, can't I? Yeah, perfect. And again, that's pi over 3. And then that's 5, and then that's 5. So these two are the same thing, right? Now, the main thing now is just to calculate that area of the triangle, isn't it? Right? How do I find the area of a triangle? Well, I've got two sides and I've got the angle between. We can just use half AB sine C for that, can't we? So I'm just going to write this here. This one, we're going to use 1/2 AB sine C, aren't we? Which would mean that it's going to be 1/2, and then A and B are both 5, so 5 times 5, and then sine of pi over 3. like that. So that's going to be 25 over 2. Whoops. Let me get rid of those. Get rid of the ink to shape. So 25 over 2 times by sine pi over 3. So let me put it in my calculator and see what that is again. So um 25 over 2 times by, my calculator is in radians, yes it is, sine pi over 3. Where's pi? Pi is there. Shift pi over 3. That is equal to 25 root 3 over 4. Okay? So this is 25 root 3 divided by 4, which is the area of this one. 25 root 3 over 4, which is the same as that one. Again, this is the same thing. And then that was 25 pi over 6. So again, what are we doing? We're trying to find out this little section in blue, which again is equal to the area of that sector, right? ABO minus the area of that equilateral triangle. We found out both of them. So now we can find out what that little section is here. So what we're going to do here, say now area is going to equal 25 pi over 6 minus 25 root 3 divided by 4. So now we've got that. Remember what we're looking for though. We're looking for this area here, ABO, right? We had the area of the sector in green, which is 25 pi over 6. We just now need to add the area on in blue, right? So I'll do this here. So I'm going to say then, just so it's super clear, this area here, right? Which was ABO, wasn't it? Yeah, ABO. ABO. This is equal to this area here, right? Plus the area of that sector, isn't it? Right? This is a, you just write them all. Yep. AB, that's AB, that's A and B, like that. And then this is A and then BO, isn't it? Yes, perfect. So the area of this one is 25 pi over 6 minus 25 root 3 over 4. And then we're going to add on this area here, which we know is just 25 pi over 6. Like that, right? So now we can just tally that up, and then that will give us, what do we have? 25, we got 50 pi over 6, don't we? Minus 25 root 3 over 4, which we can write, I'll do it here. 50 over 6 is 25 over 3, isn't it? So it's going to be 25 pi over 3 minus 25 root 3 over 4. So now we have everything we need to answer the question. Again, what are they asking us for? They're asking us for the area of that shaded region R in that format, right? Remember, we said it's the area of the semicircle minus the area of that area ABO, right? We've got both of them now. So what I'll do, how much room do I have? I'll just do it, I'll do it here. I'll do it here. I'll just do it here. So therefore the area R, this is going to equal, the area of the semicircle is 25 pi over 2. And then I'm going to take away the area of this region here, which we now know is that thing, 25 pi over 3 minus 25 root 3 over 4. Do it here. So I need to put a bracket around it though, don't I? So 25 pi over 3 minus 25 root 3 divided by 4. Let me just double check I've done that correctly. Don't want to make any mistakes. Yep, 25 pi over 3 minus 25 over 3 over 4. Perfect. So working this out, that's going to be equal to 25 pi over 2 minus 25 pi over 3. Two minuses will make a plus. 25 root 3 over 4. This right here, 2 and 3, we could put these over 6 like that, can't we? Times by 3, that's going to be 75 pi. Times by 2, that's going to be 50 pi. Plus 25 root 3 over 4. And then now 75 minus 50 is 25. So it'll be 25 pi over 6 and then plus 25 root 3 over 4. Now they wanted it in the form of a root 3 plus b pi. So they want the surd first and the pi after. So it's going to be 25 root 3 over 4 plus 25 pi over 6, like that. And let me just double check. Do they want on the outside? A root 3 b pi. So just to be extra, it's going to be 25 over 4 root 3 plus 25 over 6 pi. So therefore A is equal to 25 over 4 and B is equal to 25 over 6. And that's it. Finished. Okay, so question 12 says express 140 cos theta minus 480 sine theta in the form k cos theta plus alpha, where k is greater than 0 and alpha is between 0 and 90 degrees. State the value of k and give the value of alpha in degrees to 2 decimal places for 3 marks. Now, what I normally do when I do these questions in my walkthroughs is I actually derive it with the proof. You know, when you use the addition formulae and using sine over cosine and so on and so forth, and sine squared plus cos squared is 1, blah, blah, blah. Apparently, you don't have to do that. I have seen the mark schemes and they don't do that. And one of my students always tells me that that is long. Whenever I'm doing it in the lessons, he always messages me like, bro, that's long, like, that's long. So, somebody confirm for me if you're allowed to do, if there's any math teachers that are watching this or anyone, it doesn't have to be a math teacher, any of you guys watching this, let me know. But I'm not going to derive, I'm going to do it the way I would do it if I was just doing it quick in an exam, right? So the first thing is K, right? Normally it's given as R, isn't it? Right? It's normally like that. But in this case, if I want K, in this case, if I'm doing it quickly, it's just always going to be the Pythagoras of these two, always, right? 140 squared plus 480 squared. That is going to be your answer. So I'll put this into my calculator and see what I get for that. So shift square root 140 squared plus 480 squared, like that. That is equal to 500. So K is immediately done. That's 500. To get alpha, what I do if I'm doing it quickly is I just want to ask myself, what is the coefficient for each? So in terms of the cos theta and the sine. And that requires you to obviously know your addition formulae, because if I was to expand that out, that's going to be cos theta, cos alpha. That's a plus, so we flip it to a minus, and then sine theta, sine alpha. So I kind of inspect it with the original form. The original form is 140 cos theta, right? So that tells me that this cos alpha here, which will have a k as well, by the way, if I was to times it by k at the front, it'll be like that, k, and it'll be k like that. So the coefficient essentially is k cos alpha is 140, right? Because that is with this one, as you can see, cos theta there, cos theta there, like that. So what I say in my head is that the coefficient, I'm going to write coefficient for cos, right, is equal to 140, right? And then obviously, if I look at this one here, I've got sine theta there, sine theta there. That coefficient there is 480, like that, as you can see. But I don't really do this. I'm just writing it down because I'm explaining it to you. But this is what I do in my head. So therefore, the coefficient for sine theta is equal to 480. And because I know I want alpha, remember, we know that tan alpha is sine alpha over cos alpha or whatever, right? Because I know that, well, what is it for sine? What is it for cosine? It's 480 for sine, 140 for cosine. So it's going to be tan theta is equal to 480 over 140. So therefore, alpha is going to be the tan inverse of that. So I hope that makes sense. That's how I would do it quickly. So I don't really write all of this down. I just do it in my head. Because I know the addition formula for cos theta plus alpha, I know that the coefficient for it is going to be 140. Cos theta goes on the bottom, right, in tan. The coefficient for sine is 480. Sine theta goes on the top for tan. So the angle is going to be 480 over 140. And that's how I always do it, to be fair. So I'll just put this into the calculator and see what we get for that. So it's going to be tan inverse, shift tan of 480 over 140. And that is equal to 73.74 to 2dp, isn't it? 73.74. Yeah, 73.74 degrees. Now they did say express it in the form. So put the k and put the alpha back in. So what we're going to say here, I'll do it here. We're going to say that it's going to be k, which is 500. So the answer is going to be 500, like that. And then it's going to be cos theta plus alpha, which is 73.74. degrees. So this right here, I'll do it in the box. This right here is going to be an answer because K is 500, alpha is 73.74. So always make sure you write it like that. So yeah, that's how I do it if I'm doing it quickly. But guys, let me know in the comments how you guys do it and if I'm allowed to do it like this. Okay, so part B. Scientist studies the number of rabbits and the number of foxes in the wood for 1 year. The number of rabbits R is modeled by the equation R is equal to A plus 140 cos 30t degrees minus 480 sine 30t degrees, where t months is the time after the start of the year and A is a constant. Given that during the year, the maximum number of rabbits in the wood is 1500. Part BI says find a complete equation for this model. So to complete this model, right, we need to figure out what that constant A is. So essentially, in other words, they just ask you to find out what A is. Now, how do we go about doing that? If we inspect this model, when I look at this, this looks awfully familiar, right? 140 cosine, 480 sine, we're taking them away. We did this in part A. Remember, I just got it here just for reference. Express 140 cos theta minus 480 sine theta in the form K cos theta plus alpha. And we figured out that K was 500 and alpha was 73.74 to 2 decimal places. So what I like to do whenever I'm doing these questions is I actually just write that out again. So I'm going to ignore the constant A for now, and I'm just going to rewrite 140 cosine and then 30t like that, minus 480 sine of 30t like that. And then when you do that, you can quite clearly see that the only difference is the arguments, right? They've just changed the theta to 30t. So I'm going to just write here, theta is just equal to 30t here, isn't it? I don't know why I put a power there. 30t like that, right? So that tells me then that I can just say that this is 500 cosine of, instead of writing theta, it's just going to be 30t. And the model isn't complete, but I can update it now with this, can't I? So I can now write the model as R, which are the number of rabbits, is equal to that constant A that we're trying to find, plus, and then instead of writing 140 cos 30t, I'm going to write 500 cosine 30t plus 73.74 degrees. Now, this is super helpful because the whole point of this topic, right, harmonic identities, when you are rewriting one expression in terms of just a single trigonometric expression, is the fact that you can actually just identify what the maximum, what the minimum values are. It's just easier to use when you're solving equations. So I'll just give you an example of what I mean. So let's say I have f of x, this is an example, is equal to, I don't know, cosine of x. We know that this graph looks like this, oscillates between 1 and minus 1, right? Let's say I've got 500 f of x, right? Or 500 cos x, I should say, right? That is the same as 500 f of x, right? Because you just times by 500. But what does that do to your graph? Graph transformations. It's just a vertical stretch, and it multiplies every y coordinate by 500, right? So the new graph will look like this basically. It'll just be stretched up like that, and then I'll just say that's 500, and then that's minus 500, right? And that just comes from the fact that we know what the max and minimum of cosine is. The max of cosine is 1. So if I wanted to find the maximum there, it would be 500 times that maximum value of cosine, which is 1, isn't it? Which is 500. And then obviously the minimum is minus 500, right? 500 times minus 1. So the reason why that's helpful, let me put this, I'll put this over here. I'll put this all the way to the side. The reason why that's helpful is because we want to figure out what that constant A is, and they did tell us something about the maximum. Given that during the year, the maximum number of rabbits in this wood is 1500, right? So we know what the maximum must be. I'm going to write R max here is equal to 1500. So if I use that, right, well, that will be 1500, right? That will equal A plus 500. Now remember, for us to be our maximum in this model, this cosine expression needs to be at its maximum, right? If I just look at that without the 500, we know that the maximum of this is 1. We've seen it on the graph, right? It doesn't matter that there's a lot going on here in the argument, right? This is just going to shift it horizontally or compress it or stretch it horizontally. It doesn't affect how high or how low how high or how low the graph goes, right? The argument doesn't affect that. So we know that the maximum of cosine is 1. So that would mean when we're dealing with the maximum number of rabbits, this blue expression would have to be at its maximum. So we can say that 1500 must equal A plus 500. And in turn, that must mean that A is equal to 1500 minus 500, which would mean that A is equal to 1000. So A is equal to 1000, and that means that our complete model is R is equal to 1000 plus 500 cosine 30t plus 73.74. And that is it. That is part I. Part double I. Hence, write down the minimum number of rabbits in the wood during the year according to the model. So the maximum we know is 1500, and this is when the cosine expression is at x maximum, right? When it's 1. The minimum will just be the other way, right? R min would just be equal to, remember the model is 1000 plus 500, right? And we want the expression for cosine, this expression there, to be at its minimum. We want this blue thing to be at its minimum. It's at its minimum when it's -1. So you just put a -1 there, won't you? Which would mean that it's equal to 1000 minus 500, which is 500. So therefore, the minimum number of rabbits is 500 rabbits, right? And that is part B. Done. Let's do C. What does C say? It says the actual number of rabbits in the wood is at its minimum value in the middle of April. Part C says use this information to comment on the model for the number of rabbits. This is 2 marks. So let's put this here. So whenever you're doing these questions, when you're commenting on the model, right? I like to think of it as facts. Oh, I've done it here. I've got it pasted there, which is great, right? So this right here is a fact. The actual number of rabbits is at its minimum in the middle of April. This is what I call a fact, right? Your model, as much as possible, is trying to directly represent these facts, right? As close as possible. That's what a model is. You're trying to model something in real life, factual information. So our model, we know, is R is equal to 1000 plus 500 cosine 30t plus 73.74, right? This is the model, right? What is it saying? Actual number of rabbits is at its minimum. We know what the minimum is. The minimum is 500 rabbits, and that happens at the middle of April. So to comment on this model to see if it's suitable or not, we would need to find a value of t, plug it in, and we should hope to get something which is approximately 500, if not 500 exactly, right? How do we do that? Well, they said it's at the middle of April. What value of t is that for, right? Let's have a look at what they define t to be. They said t months is the time after the start of the year, right? T is in months, it's after the start of the year. The year starts in January. So 1 month would be February, t equals 1. 2 months would be March. 3 months would be April, right? 3.5 months, the middle of April, would be 3.5. So what we want to do is substitute 3.5 into our model. And if it's a suitable model, we should expect to get something in and around 500. So all we're going to do here is we're just going to say, we're going to plug in t equals 3.5 since it says the middle of April. So let's plug in t equals 3.5 into our formula and see if we get that. So R is going to equal 1000 plus 500 cosine of 30 times t is 3.5 plus 73.74. Let's see what we get. So plugging that in, that's going to be 1000 plus 500 cosine 30t, so 30 times 3.5, close bracket, plus 73.74, close bracket, like that. That is equal to 500.1208. It's equal to 500.12, was that 08? Yeah, 08, right? To the nearest 100, that is 500. So therefore, this is a suitable model. So what we're going to say is the model is suitable since, or as I should say, as English, Daniel, English, as when t equals 3.5, right? R, the number of rabbits, is approximately 500, which is the minimum. Minimum. And that is it for part C. Finished. Okay, so part D. The number of foxes, F, in the wood during the same year is modeled by the equation F is equal to 100 plus 70 sine 30t plus 70 degrees. The number of foxes is at its minimum value after capital T months. Find, according to the models, the number of rabbits in bold, in the wood at the time T months. So it's 4 marks. Now, they've introduced another model here for foxes F. However, the question is asking you for the number of rabbits, right? So that means we definitely need our model for R, right? Which is why I've put that there. Now, we need a number of rabbits. We need a value of R. We get values of R for corresponding values of T. So I need a value of T that I'm going to plug into this formula that will give me the number of rabbits at a certain time, right? Where do I get that value of T from? I'm going to get that from my model for the foxes. Let's read it again. We've got the foxes F, right? F is equal to 100 plus 70 sine 30t plus 70 degrees. The number of foxes is at its minimum value after capital T months. So what I need to figure out is the minimum value of F, right? Once I know what that is, I can figure out what T is, right? So, or I can figure out what T is, and then I could get F. Either way. So there's a couple ways you can do this, okay? So let me write F again. F is equal to 100 plus 70 sine of 30t plus 70 degrees. Okay. Now we want the minimum, right? The number of foxes at its minimum. We want F min. Now again, just inspect your model, right? This is a constant, right? So is this one, right? 100 plus 70, right? Where is this going to be at a minimum? It's going to depend on this thing. Again, this is just sine. The argument doesn't affect how high or how low it goes, right? So we know that this is going to be at its minimum when that is -1, right? So we can just say F min, or we could say F is at its minimum, all right, MIN for short, when this expression is equal to -1. So what we can go ahead and do is just solve this, right? Or, which is quicker, I'll do it this way. Or what you could do is say, well, because that's -1, we're going to have 100 plus 70. And we know that has to be -1, which is going to be 100 minus 70, which is 30, right? So what you could do is say, well, because we know that the minimum number of foxes is 30 foxes, right? We could say 30 is equal to 100 plus 70 sine of 30t plus 70. And then if you were to rearrange that, you're going to get to this point anyway, because you're going to take 100 away, which is going to be -70, divide by the 70, you're going to get -1. So you can do it this way, or you could just go directly here, which is what I would recommend. But the main thing is we need to solve this equation here. So sine of 30t plus 70 is equal to -1. Let's figure out what t must be. Now t is the sine inverse of that. What's the sine inverse of -1? You can use the graph to be fair, but I'll just do it on the calculator. I think it's going to be, it might be 270, but let's just check anyway. Sine inverse of -1 is -90. Yep. And then if we add 360 to that, you're gonna get 270, isn't it? So let's just draw the graph just to confirm. So the sine graph looks like that. Like that. No, that's the cosine graph, sorry. That's the cosine graph. Sine graph looks like this. Starts at 0, goes like that, and then goes like that. Right? So we can see quite clearly -1 is there. That's 90 degrees. But obviously, remember, t is positive, it's time, so we don't want that one, right? So we're going to get the next one, which is going to be over here, like that. And then that's going to be 360 after that. That's 270 degrees. So we're going to use 30t plus 70 is equal to 270 instead of minus 90, right? So that's what we're going to solve. Have I got room here? I do. So I'll do it here. No, I'll do it. Yeah, I'll do it. I'll write it here. 30t plus 70 degrees is going to equal 270 degrees like that. And then solving that, I'll complete on the next page. But take away 70 is going to be 30t is going to equal 200. That means that t is going to equal 200 over 30, which means that t is going to be 20 over 3. Perfect, right? Remember, t is positive, so we're going to use that one, okay? It's in months, isn't it? So we want this first positive value. So now I know that t is equal to 20 over 3. This is actually capital T, isn't it? Right? I'm going to write capital T is going to be 20 over 3. This is the time at when the fox is at its minimum. Part D says, find according to the models the number of rabbits in the wood at this same time. So we're going to plug in that value of T, 20 over 3, into our model for the rabbits. And that will give us the number of rabbits at that time when the fox is at its minimum. Okay? So that's pretty much it. So I'll do that here. So T equals 20 over 3 into R, right? That is going to be R is equal to, I've done this model so many times, it's 1000 plus 500 cosine of 30, and then T is 20 over 3. 20 over 3 plus, and then I feel like I've forgotten it, 30T, 73.74. 73.74. So you're just going to put that into the calculator, aren't you? So, yeah, I'll just put it in and see what we get. So it's going to be 1000 plus 500 cosine, and then 30. 3 times 2 is 6. 600 over 3 is 200. That's just 200, but I'll put in like that anyway. I'll put in like that just so it's super clear. 20 over 3 uh like that, and then plus 73.74 close bracket. I think that's it. Yeah, that looks good to me. Execute, we get 1032. So R is equal to 1032 point, what was that? 61, blah, blah, blah. And then because it's a number of rabbits, right? We just round this to the nearest whole number. So 1033 rabbits. And that is our answer. Okay, so question 13 says, given that a is a positive constant, use the substitution x equals a sine squared theta to show that the integral between 0 and a of x to the half multiplied by root a minus x dx is equal to a half a squared multiplied by the integral between 0 and pi over 2 of sine squared 2 theta d theta for 4 marks. Okay, so integration by substitution, guys. Whenever you're doing this, it's just literally algebra. As long as your algebra is very solid, and in this case, you have a good knowledge of your trigonometric identities, which you should do, then you should be fine. This is not to say that this question is easy. This is definitely a tricky question for sure, but as long as you have those tools, then you should be okay and get a couple of marks, if not all of them. So how do we start this? Remember, the whole point of substitution is you have an integral in terms of x that you don't like, you use a change of variables, typically u, but in this case it's theta, to change this integral to something that you are able to integrate. So let's get started. So what I like to do whenever I'm doing integration by substitution is, if I can find my cursor, there we go. I always just, let me write the integral again. So between a 0 and a, x to the half root a minus x dx, right? I always just plug in the substitution, right? Remember, the whole point is you're trying to eliminate x's everywhere. So let's go ahead and start doing that. So if I plug in x equals a sine squared theta, then I will get, I'll do it here. I'm just going to get integral between 0 and a of, that will be a sine squared theta to the half. And then this will be root, and then it would be a minus x, which is a sine squared theta, isn't it? So I'd get that, and then dx. Okay, so I'm here right now. Remember, we're trying to get everything in terms of theta. We're off to a good start. What can we do from here? What I would do is, there's a lot going on here. I'm going to simplify these bit by bit and then put them back in. So this right here, we'll start with this one. So a sine squared theta to the half, right? We know that's the exact same as the square root of that, isn't it? And then from our third laws, right, we know that when we have a product root a b, it's the same as root a times root b. We can say that this is root a multiplied by sine squared theta. Now, root a is fine. What is the square root of sine squared? It's just sine, isn't it? So that just becomes sine theta there. So that one is done. The next one, this one right here, a minus a sine squared theta. What can I do with that? Well, when I inspect what's underneath the square root, right, I've got an a in both terms. So immediately I'm just going to think to factorize it, right? So if I factorize it, could take out an a. It's going to be a, and it's going to be 1 minus sine squared theta, right? And in that there, you should recognize from your trigonometric identities. But before I get there, let's do what we did above. We can split this. This is a product now, so we can write this as root a and then root 1 minus sine squared, isn't it? And then as I was saying before, remember your identity. I'll do it here. Sine squared theta plus cos squared theta, is equal to 1. So if I want to get cos squared on its own, you would just take away sine squared, wasn't you? So I could replace that there, right? This is an identity from year 12, so you guys should know this. So root a, and then that just becomes the square root of cos squared. And then again, what is the square root of cos squared? It's just cosine. So that way it becomes root a and then cos theta. And that's perfect. So what I'm going to do now is I'm going to replace these two, that and that, with these simplified expressions. So it becomes the integral between 0 and a of root a sine theta multiplied by root a cos theta, right? Dx. This is where we're at so far. Whenever you're doing a show that, this is a show that at the end of the day, I'm going to screenshot it. Always have what you're trying to show at hand, just so you can see where you are and where you need to get to. Okay. So this is where we're currently at. Here's this here. We are currently here. Okay. So what can I do? Let's just tidy these up. This is fine. Root a times a root a. That's just a, isn't it? So we can write this as the integral of 0 and a. Root a and root a is just an a. Sine theta times cos theta is just sine theta. Cos theta. And then now I have dx here. So now, looking at what we need to get to, we need a d theta, right? How do we get that d theta? It always just comes from here. You need to differentiate your substitution, right? X equals a sine squared theta. So I'm going to write that again. We need to differentiate this. X equals a. And instead of me writing sine squared theta, I'm going to write as sine theta all to the power of 2. Why? Because I'm differentiating this. This is a composite function, which means that I need to use the chain rule to differentiate it. So when I write it that way, it's just easier to do it. So remember, all you're going to do is differentiate with respect to theta is going to be dx d theta. A is a constant, so we're going to multiply by that. How do I differentiate this? You differentiate the outer function, which is the squaring function. That's just the power rule. So the power is going to drop to the front, sine theta, and then we reduce the power by 1. And then now, once you're here, you're going to multiply by the derivative of what's inside, the inner function, right? The derivative of sine is cosine, so I can put a cos theta here. And then this just tidies up to become a times 2 is 2a sine theta cos theta, right? And this is dx d theta. Now remember, we want an expression for dx. So all we're going to do now is just multiply through, which would mean that dx is going to equal 2a sine theta cos theta, and then d theta, like that, isn't it? Let me just move this to the side a bit, just so I've got a bit of room. Put that there, and then just make it a bit neater. Okay. So try that a bit neater. So we got that there. Theta, cos theta, d theta. And then now I can put that there, can't I? So this dx right here, I can replace it with that, right? So now the integral that we're dealing with now becomes, I'll do it right here. It's going to be the integral between 0 and a of a sine theta cos theta d theta dx, sorry, which is this thing. So it becomes times by 2a sine theta cos theta d theta. And then from here, let's tidy this up a tad bit more. I've got 0 to a still. What do I have? I've got a times 2a, that's 2a squared. So I could put that there, 2a squared. And then I have a sine theta cos theta multiplied by another sine theta cos theta. I've got two of them, I can square it. So I can write that as sine theta cos theta to the power of 2 d theta, can't I? So this is where we're at. Remember, we need to get there. So definitely made good progress, right? Because we've got the a squared, which is great. We don't have the half though, but we don't have the 2 theta, but it's not a problem. Let's continue and see where we're at. So again, always have what you're trying to show as a point of reference, right? To see where you are currently at and where you need to eventually arrive to. So let me copy this and then let's just compare them. So copy that and then I'll put this there. Place that there, and then bring this there. Okay, so we are here, inspect it, right? Now, when I look at both of these, right, what do I notice? Well, what we have here is we actually have 2 theta, don't we? Right? Our arguments are theta, but this is something that you should recognize again, having good knowledge of your trigonometric identities. Sine theta, cos theta, that's the double angle formula. Remember, sine 2 theta is equal to 2 sine theta cos theta, isn't it? This is not in the formula book, so you definitely need to memorize this. You should memorize all of them anyway, but this one especially, right? And the ones for cosine as well. So what do we have? We've got sine theta cos theta, right? We don't have the 2. That's not an issue. Just divide by 2. If I divide both sides by 2, I'm going to have sine 2 theta divided by 2 is equal to sine theta cos theta. And that is fantastic because now I can replace that with sine 2 theta over 2. And then that way I get that sine 2 theta, which we need. So doing that, the next step is going to be the integral between 0 and a. Still got to do the limits, by the way. It's going to be 2a squared. And then it's going to be, instead of sine theta cos theta, we know that that's sine 2 theta divided by 2, all squared d theta. Fantastic. So now we are here. What can we do? Well, we're squaring a fraction. Let's expand it. Let's square it. It's going to be integral between 0 and a, 2a squared. Numerator is just going to be sine squared 2 theta, what we've got in the show that, divided by, what's 2 squared? It's just 4. So that's going to be like that, and then that's going to be the theta, like that. So this is where we are. What can we do from here? Well, this is fantastic. 2 on the top, we're dividing by 4. That is 1/2, right? So that means I can write that as 1/2, like that, a squared. And then I've got sine squared 2 theta, d theta, between 0 and a. Now remember, we're actually pretty much done. Remember, a half is a constant and so is a squared. It's a positive constant. You can always bring a constant outside of the integral. So therefore, it becomes 1/2 a squared multiplied by the integral sine squared 2 theta d theta, right? And we've done everything. The heavy lifting is done, right? The algebra is done here, right? If we compare that, the only thing we need to do now is the limits, right? Which is the easiest part, okay? So remember, we start off with an integral in terms of x, don't we? Right? So remember, at the very beginning, it was in terms of x. What I like to do actually is I always like to do x equals like that. X equals, because these are limits on the x-axis, aren't they? Right? So just to remind yourself that x is, these limits are x values. Our substitution is x equals a sine squared theta. So what I'm going to do now is get the limits, right, and show that it's going to be 0 and pi over 2. So first limit, upper limit is x equals a, right? Remember, our substitution is x equals a sine squared theta. So that would mean that a, which is x, has to equal a sine squared theta. Now, how can we show that this is pi over 2? Because that's the upper limit from I'll show that, right? Upper limit is pi over 2. Divide both sides by a. It's going to be 1 is equal to sine squared theta. Square root. So that means that sine theta is going to equal plus or minus 1, right? We need to solve this. Remember, we know that the upper limit is pi over 2, okay? Well, if I draw the sine graph, I'll do it here. Sine graph is like that. We know that we need pi over 2. Pi over 2 is over there. This is when sine theta is 1. So you have to solve sine theta is equal to 1, don't we? And we can see from our graph, you can input your calculator, that means that theta is pi over 2, like that. So that is done. Fantastic. And then the lower limit, right, is x equals 0. X equals 0. That would imply that 0 is equal to a sine squared theta. Divide through by a, you'll get sine squared theta is equal to 0. Square root sine theta is equal to 0. And you can see quite clearly that is 0 there, right? So the lower limit is 0. So now we've shown the limits here, like that. Limits here, like that. Examiner sees that, perfect. And then now you can say that the answer for the integral, I'll just put a line, I'll do it like this. Final answer, you can say, therefore, the integral is going to be between, or you know, let me write the constant first. So it's going to be a half a squared multiplied by the integral between 0 and pi over 2, right, of sine squared 2 theta, d theta. And then let's just check. Yep, half a squared. Yep, perfect. And that is it. I wonder how long that was. That was at least 10 minutes. But yeah, that's part A done. Okay, so part B says, hence use algebraic integration to show that the integral between 0 and a of x to the half root a minus x dx is equal to k pi a squared, where k is a constant to be found for 4 marks. Okay, so remember, in part A, we use substitution to rewrite this integral, right? We rewrote the integral as this one. So what we're going to do is we're going to integrate this. So the question is, how do you integrate sine squared to theta, right? Now, whenever you see these types of questions, guys, where you've got a trigonometric expression, sine or cosine, and it's being squared, right? And it's on its own, there's nothing else multiplying by it. What you want to do is use an identity to reduce that power. So essentially at A-level maths, we don't really know, or we're not really familiar with how to integrate sine squared or cos squared, right, on its own. What we want to use an identity to rewrite that as a power of 1, right? We want to reduce that power from 2 to 1 because we know how to differentiate sine to the power of 1 or cosine to the power of 1, and we know how to integrate it as well. So what can I do that will allow me to replace that? Well, it's very, very simple. This is a key clue here, right? Sine squared, we got a 2 theta. It's a double angle formula. So I'm going to write that. And which one are we going to use? We're going to use the one for cosine. So what we know originally is cos 2 theta is equal to 3, right? There is cos squared minus sine squared, and then there is 1 minus 2 sine squared theta. Then there is 2 cos squared theta minus 1, right? Because we want to change the sine squared, we're going to use the middle one. We're going to use this one here, like that, right? And what that means is, if I was to rearrange that, let me just get rid of, you know what, let me not get rid of it. Let me just write like that. So if I was to get that there, then that would mean that cos 2 theta, right, is equal to 1 minus 2 sine squared theta, which algebraically would mean that if I move the 2 sine squared to the left, 2 sine squared theta to the left, and I move the cos 2 theta to the right, I have 1 minus cos 2 theta. And then if I divide by 2, I'm going to have sine squared theta is equal to 1 half minus 1 half cos 2 theta, isn't it? Okay. Now, if I must integrate that, then it's just integrating that, and that is easy because that is just going to become theta. That's just going to be integral of cos is sine, right? So this is how we do it when we have these types of questions. Now, remember, we don't have sine squared though, do we? Right? Our argument, our angle is 2 theta. So look at the relationship, right? If this is sine squared, if this angle is theta, the one on the right is 2 theta. So if this is 2 theta here, we have to double that angle on the right, don't we? And that's going to be a 4 theta. So what we can do now is actually replace the sine squared 2 theta with a half minus a half cos 4 theta, okay? So therefore, we can say that we're just integrating now between 0 and pi over 2. And it was a half a squared on the outside, wasn't it? Yep, half a squared. And then 1 half minus a half cos 4 theta d theta. And this is what you should always do, guys. I think this came up, I'm not sure. Did it come up in 2022? I'm not sure actually. Don't quote me on that. But yeah, this has come up before. I can't remember what year, where you have just sine squared or cos squared, and you have to use an identity, the double angle formula identity, to reduce the power. That's the whole process behind it, reducing the power. So now we're here, we can get started. Because I've got a half a squared on the outside, got that there. Now let me put the limits in here. So 0 pi over 2. Now 1 half, we're integrating with respect to theta, so it's going to be a half theta. I've got minus a half. That's a constant. How do I integrate cos 4 theta? Well, remember, this is the reverse chain rule. We know that cosine integrates to sine, so it's going to be sine 4 theta. Sine 4 theta. One sec. Yeah. What is it for? Okay, perfect. Sine 4 theta. I need to do the laptop to be honest. Sine 4 theta. And then once you've integrated that, you're going to divide by the inside differential. So when we differentiate 4 theta, we get 4. We divide by it. So we're going to times by a quarter, aren't we? And obviously we were times it by minus a half. So let's just tidy that up a bit more. So it's going to be a half a squared on the outside. And then it's going to be 1 half theta minus, and then an eighth, isn't it? An eighth sine 4 theta. And this is between pi over 2, and 0. So we're just literally evaluating that. So let's do that. Plug in the upper limit is going to be 1/2 pi over 2 minus 1/8 sine of 4 times, we put a bracket, times by pi over 2, like that, minus, and then I haven't forgotten the half a squared, by the way, so I'm just doing let me write out this actually so it's super clear. So big bracket like that, and then there's a half a squared on the outside, isn't it? Okay, and then the lower limit, if I plug in 0 to each of these, well, that's going to be 0, and so is that, isn't it? Right, so it's just 0 there, essentially. So I could cross that one out, and then I just need to evaluate that. So that's going to be a half a squared, and then what's that? That's going to be pi over 4. That's going to be pi over 4. That's going to be minus an eighth sine 4 pi divided by 2 is 2 pi. That's going to be 2 pi, like that. Let me just zoom out a bit so it's a bit clearer. And then I'll do it here. That's a half a squared, like that. Pi over 4 minus the side of 2 pi. You can put your calculator, that's just 0, right? So that's all 0. So therefore, it's a half a squared times by pi over 4, which we can write as 1/8 a squared pi, like that. And then what form do they want it in? K pi a squared. K pi a squared. So let me swap the a squared and pi. So it's going to be an 1/8 pi a squared. And you can see quite clearly k has to equal 1/8. And that's it. That is question 13 finished. Okay, so question 14. A balloon is being inflated. In a simple model, the balloon is modeled as a sphere. The rate of increase of the radius of the balloon is inversely proportional to the square root of the radius of the balloon. At time t seconds, the radius of the balloon is r centimeters. Part A says, write down a differential equation to model this situation for 1 mark. Okay, so differential equations, right? What are we dealing with here? What variables, right? We're dealing with the radius, right? And this is at time t seconds. So our variables are definitely going to be r and t. Now, we want a differential equation, so we need a derivative. Let's look at the bullet points, right? The ball is being modeled as a sphere, it's being inflated. The rate of increase, right, of the radius, right? So what I always do when I'm doing these types of questions is do it bit by bit. The rate of increase, whenever you see that word rate anywhere in A-level maths, right? It's to do with the gradient. It's dy dx. It's your derivative. So for me, when I see this, the rate of increase of the radius, that is the radius changing. So that has to be dr for sure, right? The rate of increase of the radius of the balloon is inversely proportional, right? Well, think about it like this. Before we get to the inversely proportional part, what is happening as the radius is increasing? Time is going on, right? So from there, I know this has to be dr dt. Okay, so what I'm going to do is say, first of all, dr by dt is going to be the left-hand side, and this is going to equal what? Well, let's continue. This is inversely proportional, right? So straight away, GCSE, inversely proportional, your constant of proportionality goes on the numerator, right? This is inversely proportional to the square root of the radius. Square root of the radius of the balloon. The radius of the balloon is r, the square root of r is just root r. So it's literally just dr dt is equal to k over root r. And that's how you always do these questions. Just do it bit by bit. Look for that word rate, right? Rate of increase of the radius. The radius is changing with respect to what? With respect to time. So it's dr by dt is inversely proportional, k over square root of r. That's it. So that's part A. That's 1 mark in the bag. Okay. So that's done. Let us continue and go to part B. What does part B say? It says, at the instant when t is equal to 10, the radius is 16 centimeters. The radius is increasing at a rate of 0.9 centimeters per second. Part B says, solve the differential equation to show that r to the 3 over 2 is equal to 5.4t plus 10 for 5 marks. Okay, so in part A, we had to form our differential equation. In part B, we have to solve it. Now remember, whenever you're solving differential equations, you separate the variables, integrate both sides. You're going to get your constants. You find out what your constants are, and that will give you a particular solution, right? Once you solve it and you haven't got your constants, that's the general solution. The bit of information given to you here will allow you to find your constants. So let's go ahead and start doing that. So what I'll do is I'm going to put part B here, and part B we know that we're solving this differential equation. dr dt is equal to k over root r. So that can go there. And then let me just get part B actually as well. I should have got this beforehand, but we'll see how we get on. So this is what I need. And I need that as well, because that's the actual question, isn't it? It's to show that. So always have what you're trying to show at hand. I say this about 3 times a walkthrough. Okay. So where are we? We need to separate the variables. That's the first thing we're going to do. So I'm going to bring the r's with the drs and then the dt's with the t's, but there's no t's here, so I'm just going to times with the k, the constant. So if I times both of them like that, cross multiply, then that's going to be root r dr is equal to k dt. And then that there is r to the half, that's dr, and then that is k dt. So we need to integrate both sides. Now immediately when I do that, I know that I'm gonna have, or let me write like this. Let's just actually do that. So we're gonna have add 1 to the power is gonna be 3 over 2. Divide by the new power is divided by 3 over 2, but that's the same as multiplying by 2/3, isn't it? So I'm gonna put that as 2/3 on the outside, like that. And then this is going to equal, we're integrating a constant k with respect to t. That's going to be kt plus our constant of integration, right? We've got 2 constants here, so we need to find 2 values, okay? Let's look at the information given to us. They said at the instant when t is equal to 10, the radius is 16. So let's write that. When t equals 10, what do we know? We know that the radius is equal to 16. And what we also know is that the radius is increasing at a rate of 0.9 centimeters per second. Again, when you see that word rate, that is dr by dt, is it? That is just dy dx, right? In this context, it's the radius, so it's dr by dt, and this is equal to 0.9, okay? And another thing to help you as well, look at the units of measurement, right? A rate, look at the unit. This is centimeters, isn't it, right? Centimeters is the radius, right? dr per second. That's time changing, that's dt. So when you look at that, that always helps you, or helps me anyway, to figure out what the actual rate is, what the actual expression is that I'm going to be dealing with, okay? So we need to figure out the values of k and c. We've got this information here. Now, what we do know originally, right, is what dr dt is, right? dr dt is equal to k over root r. And we know that we're looking for that constant k, isn't it? Can we use this to help us out? For sure, right? Because remember, this is when t is equal to 10. We've got 2 things. The radius is 16 and the rate of increase is 0.9. So what I can do is say that when t equals 10, I'll write here. When t equals 10, we know that dr dt is 0.9. And we also know that the radius is 16. So it's k over root r. So root 16, like that. And then from there, we can figure out what k is, because that's just going to be 0.9 is equal to k over 4, which means that k times both sides by 4, 0.9 times by 4 is 36 divided by 10, isn't it? So k is equal to 3.6. I can put that in there. So therefore, I can update this differential equation. So it's going to be 2/3 r to the 3 over 2 is equal to 3.6, isn't it? 3.6 t plus c. Now I need to figure out what the constant of integration is. How do I do that? Just by using this initial conditions now. When t equals 10, r is equal to 16, okay? So doing that is going to be 2/3, and then it's going to be 16 to the 3 over 2 is equal to 3.6 times by 10 plus c, isn't it? And get my calculator. I think I've done it here already. Yeah, 2 over 3 times 16 to the 3 over 2 I've done here. That's 128 over 3, isn't it? So that can go there. 128 over 3. And this is equal to 36, isn't it? 3.6 times 10 is 36 plus c. And then that means that c is going to equal 128 over 3 minus 36. And that is equal to, let's put that into the calculator and see what we get. So it's literally going to just be answer minus 36, isn't it? So shift answer minus 36. That is equal to 20 over 3. So that means that we've got everything we need now. So that means we could say that it's going to be 2/3 r to the 3 over 2 is equal to 3.6 t plus 20 over 3. Now remember, it's to show that we want it in a certain form. in the show that they just want r to the 3 over 2, right? They don't want the 2/3. So what we can do is, to get rid of that, we can just times these by 3, divide by 2, right? To get rid of the 2/3, we times by 3, divide by 2. That's going to be r to the 3 over 2 is equal to, times that by 3, divide by 2. I'll just put it in the calculator because it's a decimal. 3.6. 3.6 times 3 over 2. That is equal to 5.4. So I get 5.4 t plus, and then that one's easy. Times that by 3, the 3's cancel. Divide by 2, that's 10. For sure. You don't even need a calculator for that one. And if we look at the show that's exactly what they got. R to the 3 over 2 is equal to 5.4t plus 10. And yeah, that is part B. Done. I think that's a very easy and a very straightforward 5 marks, isn't it? Right? Just as long as you've got your tools, you know you need to separate the variables, use the information given to you to find the constants, and you're fine. I think this is a very nice 5 marks for sure. So that's part B. Let's do part C and D in a separate one. Okay, so part C. It says, hence find the radius of the balloon when t equals 20. Give your answer to the nearest millimeter for 2 marks. Okay, so this is just a matter of just substituting 20 into the formula. So it's going to be equal to r to the 3 over 2 is going to equal 5.4 times 20 plus 10. Right? That's literally all you're doing. What's that? 5.4 times 10 is 54. Double that, that's 108. Add 10, that's 118. This is 118. And then r to the 3 over 2. So now we need to get r, right? We just need to, that's to the power of 3. So we need to cube root it and then we square, don't we? So it's going to be the cube root of 118 all to the power of 2, isn't it? To get that. So put that into the calculator. What do we get? It's going to be, where is it? It's going to be shift that one, isn't it? Yeah. Cube root 118. And then we're going to square all of that, aren't I? So that's going to be, whoops, need to put on that side. So it's going to be like that. And that is equal to 24. This is in centimeters, isn't it? The radius is in centimeters, right? Let's double check. Yeah, it's in centimeters. So nearest millimeter is the same as 1 decimal place for centimeters, isn't it? So we can write that to 1 decimal place, which is going to be 24.1, 24.05, blah, 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 which is 24.1 centimeters. But as in millimeters, we just times that by 10, isn't it? So your final answer is going to be 241 millimeters. Perfect. So that's done. Part D, suggest a limitation of the model. Well, what are we modeling? What does it say at the beginning, right? A balloon is being inflated. In a simple model, the balloon is modeled as a sphere. The rate of increase is inversely proportional to the square root of the radius, right? And what we've got here on our model is the time changing as the radius is changing, right? So what is wrong with that? Well, as t gets bigger, so will r, right? But remember, this is a balloon. It's gonna pop eventually, right? The model doesn't account for any of that, right? It just says as t gets bigger, r is gonna get bigger, right? There's nothing about it changing or stopping at one point, which we know will happen in real life. So the problem is that the model, according to the model, the radius will continue to increase without bound. This isn't possible as the balloon will pop eventually. As the balloon will pop eventually. Something along those lines. Just as long as you just relate it to the fact that the radius can't keep increasing, you put it in context. Remember, the balloon is being inflated. Balloon's gonna pop eventually, right? There's nothing about the model that signifies that. So yeah, that would be your part D. And yeah, that's it. Okay, so part 15i, show that k squared minus 4k plus 5 is positive for all real values of k for 2 marks. So we have a quadratic, we want to show it's positive for all real values. You cannot go wrong by drawing a diagram, right? You don't have to draw a diagram. You can use the algebra, but for me, I'm a visual learner. Look at something. There's no way I can look at something and not understand it. So that's what I would do. So what I want to do is sketch this. So I'm going to complete the square to get the turning point. So if I complete the square on that, it's going to be k minus, we have the minus 4 to be 2. Take away the square plus 5. So that's going to be k minus 2 squared. Minus 4 plus 5 is a 1, so plus 1 like that, which means that the turning point is going to be positive 2. You flip that, positive 2, and then 1, right? So if I was to sketch that, right, what would that look like? Okay, well, the turning point we know, the turning point is at 2, 1. So let's just say 2 is there. Let's say 1 is there. The turning point is right there. The y-intercept is 5, right? So it's going to be a 5 there. This is the k-axis. That's the y-axis, like that. And then the graph, which is going to be a parabola through those points, like that. K squared is positive, so we know it's going to go that way. And yeah, this is the graph of y equals k squared minus 4k plus 5. And what we can see quite clearly is that the minimum value, right, is 1, right? So what I can say in terms of my proof or showing that it's positive is that the minimum value is 1, is 1. So therefore we can say quite clearly that k squared minus 4k plus 5 is greater than or equal to 1. Doesn't go below 1. Since it doesn't go below 1, it must be positive. So then I can say, therefore, k squared minus 4k plus 5 is positive. So just write what you're trying to show again, just to prove it. Positive for all real values of k. And that's literally it. You can't go wrong with a picture. You can see it, right? The graph is above above the k-axis. It's above 1. It's 1 at the minimum, goes up, right? So it's entirely positive, isn't it? And that's it. Finished. Okay, so double line. A student was asked to prove by contradiction that there are no positive integers x and y such that 3x plus 2y times 2x minus 5y is equal to 28. The start of the student's proof is shown below. Assume that positive integers x and y exist such that 3x plus 2y times 2x minus 5y is equal to 28, right? If x plus if 3x plus 2y is equal to 14 and 2x minus 5y is equal to 2, because obviously 14 times by 2 is 28, right? 3x plus 2y is equal to 14, 2x plus 5y is equal to 2. Solve this simultaneously. We get x equals 74 over 19 and y equals 22 over 19, which are not integers, right? This is a contradiction as we assumed here positive integers x and y, right? We assumed right here. So that is a contradiction. Question says, show the calculations and statements needed to complete the proof. So we've started it. So remember, we're dealing with proof of contradiction. We assume the opposite, right? And then obviously we look for contradictions. So the start of this one is we've got a pair of factors of 28, 14 and 2. We've solved it simultaneously to figure out what x and y must be, right? But this is a contradiction because even though they're positive, they aren't integers, okay? So what we need to do is go through all of the possible pairings and solve this simultaneously. So what I would do with this type of question is just list them out. So I've got the number 28. So what are gonna be the possible pairings? I'm gonna put them in brackets like coordinates, right? So the first one is gonna be 1 and 28. The next one's gonna be 2 and 14. Next one's gonna be 4 and 7. Okay. And now what I can do is I can just swap those over, right? Because remember, multiplication is commutative. I can change the order around, right? So I can say then I could also have 28 and 1, right? And then I could have 14 and 2. And then I can have 7 and 4, like that, right? These are all pairings of numbers that when you times them, you get 28. Are they the only pairings? No, because remember, two negatives make a positive. So I can just put minus signs on all of these. So I'm gonna put positive pairings here, right? I'm gonna write these here, and then I'm gonna have negative pairings on that side. So negative pairings on this side, like that. Hold on, that looks very bad. Let me write it again. So pairing like that. So we're just gonna put negative signs, aren't we? So it's gonna be -1 minus 28 It's going to be minus 2 minus 14. It's going to be minus 4 and minus 7. And then it's going to either be, let's swap these over again. So minus 28 minus 1, minus 14 minus 2, and then minus 7 and minus 4. What we need to do is go through each of these pairings and show that x and y are integers or they're not positive or so on and so forth. Now, they've done one of them. They've done one of them for us. They've done this one, haven't they? 14 and 2, right? Now, there's quite a few here. How many? We got 1, 2, 3. We got 12, right? They've done one. We've got 11 to go through. Are there any pairings that we can immediately disregard without having to actually do the algebra, right? This is the type of thing that you want to do. Now, there are, because immediately, remember, we assume that x and y are both positive, right? So let's go through our justifications as to what ones we can just immediately disregard. We know that x and y are both greater than 0, right? If that's the case, then surely 3x plus 2y has to be greater than 0 for sure, right? 3x plus 2y, right, is the factor on the left, right? Or in any case, it's one of the factors, right? So what that means is that any pairings that have a negative factor, I can immediately disregard, which are all of these on the right, right? So what I can say here is that since 3x plus 2y is greater than 0, it means that this means that I can immediately disregard all negative pairings. I don't even have to check those, right? Don't even have to check those. So therefore, I can actually just cross these out. So I can just do that. I can cross them out like that. I don't need to look at these, which means that we have to look at the positive pairings, okay? So when I look at these, well, let's inspect this again. We've got 3x plus 2y. We know that x and y are positive integers. What's the minimum of x? What's the minimum of 3x plus 2y? What's the minimum that expression can be? Well, what we can say is that, well, x and y at its minimum has to be 1, right? I'm going to say I'm going to write the minimum of 3x plus 2y is when x equals 1 and y equals 1, right? For sure. And with that being said, that would mean I'd have 3 lots of 1 plus 2 lots of 1, which is equal to 5. And that tells me that 3x plus 2y, right, has to be greater than or equal to 5, right? So 3x plus 2y, if we look at it, right, is the factor on the left. We've got a factor on the left, we've got a factor on the right. The factor on the left is 3x plus 2y. We know that this has to be greater than or equal to 5, 5 at the minimum. So that immediately tells me I can disregard any pairings which has the left factor less than 5, which are these right here. I can cross that out, cross that out, cross that out. Let me just write this here as well. So with that being said, what that tells me is that from that, let me write, so I can also disregard any pairings with the factor on the left, which is less than 5. Right? So that means I can get rid of these, right? And all I need to do is just check these 3 in the middle. But they've already done one of them for us, 14 and 2. So the only ones I need to check, right? So I can write this here. So only pairings I need to check. Whoops, need to check are 28 and 1 and 7 and 4, right? Because the first factor is more than 5, isn't it? Both positive. So those are the ones I need to check. So all we're going to do now is just do the algebra on that. So let's do that. So we'll do the first one. So let me write 28 and 1 here. That would mean I have 3x plus 2y is equal to 28. And 2x minus 5y is equal to 1. Right? Let's just double check I've written those correctly. Yeah, that's fine. So let's put this into the solver and see what we get. So let me, okay, need to minimize that. So it looks like that. That's good. And then let me just drag that down. Perfect. Okay. So where is the solve? I think it's there, isn't it? So that one. Um, F1, I need simultaneous. I want two unknowns, so we'll click that one. And then I'm just gonna put those in. So I'm gonna have 3, I'm gonna have 2, I'm gonna have 28, and then I'm gonna have 2, I'm gonna have -5, and I'm gonna have 1. And that gives me 142 over 19 for x and 53 over 19 for y. So let me write that down. 142 over 19. So that gives me x equals 142 over 19. And this one, y, is going to give me, was it 53, wasn't it? Let me just double check that. 53. Yes. Perfect. So that's done. Okay. These aren't integers, right? So I can write not integers here. So that one's done. Let's do the other pair, right? I think I've got room here. What was it? It was 7 and 4, wasn't it? Just write 7 and 4 like that. It's gonna be 3x plus 2y is equal to 7. 2x minus 5y is equal to 4. Plug those in and see what I get. So that's gonna be I'm gonna go back. I'm gonna change that. I'm gonna just change this to 7, aren't I? So change that to a 7 like that, and then change that one to a 4. Change that to a 4 like that. And then I get 43 over 19 for x. So x equals 43 over 19. And then y is going to equal, what is y? 2 over 19, right? 2 over 19. Again, these are not integers. So the only two that we had to test, right? The others we didn't need to say, we know that they don't work. The only two that we had to test also don't work, right? Because remember, we assumed that x and y are positive integers, right? So what we're going to say now is, to finish off, this here, what we've just seen is a contradiction, right? Always state the contradiction, since we assumed x and y are both positive integers. Yeah. And now you just write the statement. What did the question ask us to prove? Prove that there are no positive integers x and y such that right. So you just, what I always do, I just literally write this. I'm just going to screenshot it, right? But what you would do in an exam is just write this out. Just my handwriting with this graphics tablet is a bit all over the place. So what you're going to do in an exam, you're just going to literally write your statement, write the contradiction, and then you're going to write, so therefore, and then just write what they asked you to prove. So therefore, there are no positive integers x or y such that 3x plus 2y times 2x minus 5y is equal to 28. And that is it. You're done, right? Another thing as well that I realized as well when I was just doing this is, when you inspect this, right, we know that 3x plus 2y is greater than or equal to 5, right? 2x minus 5y, right, is going to be smaller than that, isn't it? Let me just do a little caveat. So we know that 2x minus 5y is going to be smaller than 3x plus 2y, isn't it? Because 3x is bigger than 2x, right? So we know that part is fine. We're adding on an integer because it's positive, right? We're taking away something here. So wherever x and y are, right, it has to be smaller. 2x minus 5y has to be smaller than 3x plus 2y, which will always mean that the factor on the left is bigger than the factor on the right. So we could have also used that to justify why we're choosing the pairings in the middle, right? The factor on the left has to be bigger than the factor on the right. So we're just choosing them. But yeah, that is it. And that is the entire paper finished. Wow. Paper 2 to go now, and 3. Hey guys, Daniel here. Hope you guys are doing well. So yeah, that is the paper done. All 15 questions. I'm hoping that this walkthrough has helped you, and it's deepened your understanding and has put you better in a better position for your exams next summer, which seems a million miles away now, but time goes like that, doesn't it? So I'm sure you guys are just revising every day and making sure that you keep on top of things. And yeah, paper 2 will be out shortly. I'm sure it won't be too long after this video is uploaded that paper 2 will be out, and then eventually paper 3. Yeah, also as well, if anyone interested, I do offer group classes on a weekly basis for year 12s and year 13s, and also year 10s and 11s as well. So it's a class every week. So A-level classes are every Wednesday, 6 o'clock for year 12, 7:30 for year 13. For anyone that would be interested in that, you just go to mathswithdan.com/courses. I'll put all of the relevant information in the description as well. But largely, and most importantly, should I just say a big thank you for all of the support, guys. Every single share, every single like, every single comment goes a long way. So hopefully we can reach that goal of 10,000 subscribers by the end of the year. So yeah, it's October now, by the time this video is uploaded. So hopefully that gives us enough time. But if not, doesn't matter. You know, we'll get there eventually. But your support is always appreciated. But yeah, that's it for the video. Again, I hope you found it helpful. Always leave a comment, like, and subscribe. That always helps the channel grow. So yeah, have a good rest of your day, whatever time it is, and I'll see you for paper 2. Take care. Bye bye.